Okay. So I will also like to share a little bit about the activities and the engagements that we see in the market around AI. And again, like what Google sees, this like the third major technology wave, yeah, AI. And if you are dipping your toes into it, dip onto your knees right now, go fast, because it's really, really changing a lot of things. How people buy things, how people make decisions, how people transform customer experience, how people even build applications, how people code is AI assisted. So if you're not in that in the next couple of years, then you'll be just slower, that's all, right? Okay. So what we're seeing is a lot of customers are beginning to do pilots last year. They're starting to test things out. But many customers right now, they want quick wins now. Yeah. A lot of customers, they don't jump straight into, oh, I want to do full transformation. Nobody does that normally. Quick wins, scale it at an enterprise level, and then go transformative. So when we talk about quick wins, there are a few best practices that we see in AI, Gen AI especially. So I'll just share with you before I end. So number one is start with existing processes or areas that you can improve with AI. Yeah, don't jump into, wow, I want to do totally new bespoke area nobody knows about. Go look at existing processes, existing work, existing areas that you can use AI to drive efficiency. Prove a point first. That's number one. Number two, when you introduce AI into your organization or in your school, make sure that you train people. Yeah, you train yourself as well. Go for certifications, Gemini certifications. There are no others, right? Are there any others? Yeah. Go for Google Cloud certifications. But let's say you start a pilot project on Gen AI, you must be able to bring people together and say, look, I'm going to teach you how you're going to do this, how it will change the way you work. Have trainings for them. That's number two, best practice. Now, third best practice is how you measure it. Now, a lot of our CEOs says, okay, how will Gen AI make me more money? Fair question, right? How will Gen AI reduce costs for me? Okay, you're all developers, for example. I allow you to use AI to do coding. After you use AI, I expect 30% increase in revenue. Is it fair? It's very difficult. Even to expect, okay, now that you're using AI to build my application and the CEO, I expect 30% increase in uptake tomorrow. So it's very difficult. So a lot of AI projects, we suggest measure the leading indicators. Leading indicators are not the final indicators. Final indicators make money, right? Realistic. I want to increase to 1 million subscribers on my app. That's a final destination. But leading indicator is, okay, I measure how fast I can launch my codes, how fast I can launch my versions, because that will actually translate to better customer experience and then adoption. How fewer bugs that I can launch in my applications, because that will translate to fewer disruptions and better customer experience and delight. You delight the customers. Maybe you want to measure how happy the developers are. They come on Saturday mornings now. They don't have to code throughout the night. Those are leading indicators. So in driving quick wins, always measure the leading indicators. Okay. Then eventually it'll take time before it has a direct correlation. It's making money now. It's producing better applications. Customers are happier. Okay. All right. So there are 8 major areas of Google products that were highlighted in Google I/O. Right. I mentioned some of them. Go and figure out what the 8 are. Right. And for those of you who are you familiar with what Gemini is? Can somebody tell me what Gemini? Yeah. Okay. Congratulations. Right. Let me start with the public, the ones that everybody sees. Gemini.google.com. So that's your public Gemini that you can. So now you have Gemini Advanced with a more powerful engine in the back called Gemini 1.5 Pro. So the Gemini 1.5 Pro is the LLM. Gemini that you see is the service itself. Yeah. And then you have Gemini 1.5 Flash, which is cheaper but lower latency for better real-time communications. You have Gemini Nano. What is that? Oh, models that you can embed in phones. So how many of you uses Samsung S24? Expensive, right? Damn expensive. Yeah, so it uses Gemini Nano. Then you have, so think about, and then you have Gemini for developers. Oh, what is that then? It's the Gemini that you have when you open Google Cloud Console and you can start chatting around Google Cloud. You have Gemini for workspace. So we use Gemini across it. Gemini, awesome. So we use the term Gemini across our AI products, but know the differences, know the nuances. Then it's easier for you to understand. Otherwise, when somebody says Gemini, say, which one is this? Yeah. So have clarity for yourself. Yeah, I hope today you will take a lot away from all our great speakers. Some of them are pretty technical. But you know what's one secret about tackling technical or very complicated topics? Anyone knows what's the secret? I think I don't have specs, that's why you're so quiet. Okay. Anyone? What's the one secret that, I mean, you guys are all smart people. How do you tackle very complicated topics that is foreign to you, for example? Anyone? Sorry? The old new way. Let's go for a new way. What is ChatGPT? Organizers. No, ask Gemini. Yeah, of course. Ask the questions. Be brave about. I mean, we're all Malaysians. Sometimes we're very shy in class. I dare not ask questions. Takut malu. Nampak bodoh nanti. So number one, don't be. In Google, we believe we have this value. Okay, under Google, in Google, Googliness is our culture. Googliness has 6 attributes, and 2 of them are very powerful in these situations like this. Number one is thriving in ambiguity. It means that, hey, nobody knows. So I step out and let's try to figure out what's the structure so I can start understanding. So it's okay to ask silly questions. Actually, I don't understand what you're talking about. Like, Michael, I don't know what you're talking about at all. It's okay. Then you get clarity for yourself. Second one is valuing feedback. When you put it out, don't be afraid to test it out. So what if you fail? Like, just get feedback from other people. Hey, this is right, this is wrong, this is right. And then that way you get to the right answer much faster than before. Okay, and the new way is ask Gemini. Ask meaningful questions, ask rich questions. Okay? All right, guys. I'll end my keynote here. I hope you all have a great day today. Please, so the next speaker, please ask him the toughest questions. Wei Chung is in my team, so ask him all the tough questions. Don't ask me the tough questions, ask him the tough questions. All right, okay. I think that's all. Thank you so much. Thanks for your time.
Thank you, Michael, for the keynote. Next up, we will have our first talk of the day about improving factuality of your Gen AI app. It will be presented by Wei Chung right here. He is our customer engineer at Google. So let's welcome him. Yeah. We also have another track ongoing at the same time at level 20. It will be about Vertex AI Gemini, presented by Bagus. He is our technology architect of OCBC Malaysia. So if you are interested on that talk, you can head down to level 20, else you can stay here for this talk.
Hello, good morning. Can you hear me right? Hi, my name is Wei Chung. So if you attend my session before, I always like to start something funny. Right? Don't feel bad that if you want to attend my session and you miss the latest session, no, the next track, right, in level 20, right? I'll show you how to do the level 20 in a few minutes using Gemini or something. Yeah. So you attend my session, you got 2 tracks covered. I'm just joking. Sorry. All right, so yeah, see if we got time, I'll show you how to do quick prompting using Gemini, right? Let Gemini to help you prompt rather than you prompt yourself. But now prompting also no need to do yourself already. What else you can do? Right? Okay, so don't tell me about ChatGPT, yeah, bro. My boss not happy with me. All right, okay. I think in my previous 2 sessions, we talked about hallucination, big word, right? I want to show you what hallucination is. I give you the example last time about Air Canada, where the customer go to ask for a refund. The chatbot said, yes, there's a refund policy. Actually, there's no refund policy. So let me show you another good example. What just happened to me yesterday, where the customer said, hey, Wei Chung, can you help me to find out how to list out all the user that is granted to BigQuery? Right? I said, yeah, okay, good question. So I go to do some Google search. But now being the Gen AI era, right, we don't do Google search that much. We use Gemini straight away because we have fit inside our Gemini. So I call Gemini and say, how to list out all the users who have access to the BQ's dataset? Ping, right? I don't need to learn how to prompt, I just ask. Gemini say, in Google Cloud Console, you can do this, you know. You can use a BQ command line too, but it never tell you how to do this. Oh no, actually they did. Okay, BQ get IAM policy. Wow, I'm very happy. So I just go to share with my customers without verifying it. Then my customer say, bro, got error. Then you know what's the error? There's no such function called get IAM policy in the BQ command. Hallucination. Okay, I'm not trying to show you how underperformed the Gemini is. Trust me, ChatGPT also got some issue like that. Okay, I always try ChatGPT and Gemini with my kids' secondary school homework, either English or Maths. Sometimes Gemini got it right, sometimes ChatGPT got it right. So I always cross check with these 2 LLM. I never check Llama because I know they are not there yet. All right. Okay. So this is what I call hallucination. They create the fact themselves. Okay, so and why this happened? Because you notice that the get IAM policy, so-called function, is actually quite common in most of the Google command prompt. But, right, the but is in the BQ command prompt, it calls show. So the actual command is BQ show, right? But it's all the same. It's just that this word is wrong. Okay, so this is a good example of hallucination. But I hope that you guys don't take it wrongly as then I don't use Gemini anymore. Please, don't give me a chance. Okay, now, why I'm actually showing you this, because we are talking about RIG, right? We are talking about grounding. This is why grounding is so important, right? So when I show you some facts, I'm telling you this is the best of the world, but how right am I? So I still remember last year, July, when Gemini just coming out, I was happily doing a demo with a series of Toyota catalogs. Then I happily go to one of my customer that start with C, luckily not Toyota. So in fact, I went to Kasam. I showed them, you see, this is how Gemini can do. Catalog search, you can ask them any questions. So I asked Gemini, give me an example of Toyota sport car. Then it showed me about the 86 series, It tell me about the Cobra something. I mean, this is all the US model. Huh? Then suddenly I was saying, give me an example of SUV in the Toyota's catalogs. But unfortunately, I forgot that I don't have a SUV car model in my catalogs. But without knowing it, I asked this question. Then Gemini said, first time, huh? He says, oh, sorry, there's no SUV model in Toyota. Fantastic. I was so happy. Then I was like telling all my customers, you see, Gemini is so smart. Who knows, the next day I go to another customers, it start with M, buy to car. I do the same demo. Give me a SUV model about Toyota. Then it show me the result of Honda CR-V. Another example of hallucination, right? So since then, we know that this is something very, very serious. All right, especially imagine you go to Maxis, they're selling them this thing, then it suddenly is a proposed package come from Cellcom DG. Die. Or you go to Cellcom DG, they show you the package of U Mobile. Right. So that's actually what we always be very mindful when we approach customers. Okay. And of course, the time there's no such word as grounding yet. Okay. RNG is kind of new during the time. All right. So today we'll talk a little bit about grounding. At first, I have prepared a demo on how to do RNG and grounding in the coding manner, Python code line. But then after that, I found that I show you coding not nice because you can easily find the GitHub in Google search and you can run the code yourself. So I have another demo to show you later on how grounding can be very important right now. So I think in just a few examples, I explained to you why grounding is important, because grounding technically set a line between your contexts, okay? Especially you go to a customers with a brand. For example, you go to Malaysia Airlines, don't talk about AirAsia. Go to AirAsia, don't talk about Singapore Airlines. Yeah. So that is a very layman example. So the importance of grounding is to make sure that the fact is true, applied to the particular context. Again, layman term, apply to the customers, apply to the company, and so on, right? And most importantly is up-to-date information. So I give you another example. I do a demo for Petronas. I do a lot of demo on Gemini because last year I only sell Gemini. All right. So I go to Petronas, I upload their financial results, and last year is 2023, right? And you know that the latest financial result we can get is always T-1. So the latest I have is that, of course, the 2022 year financial results. So I go to Gemini and ask, that time it's not Gemini yet, that one is still called Bart, right? So I say, hey, what is the net profit of last year? Gemini won't know last year is what, right? Because you're asking this question in year 2023. And by right, the last year should be 2022. But the document that you supply to them, the latest is 2022. So the last year refers to 2022 or 2023. Okay. But this kind of question has been all resolved. Okay. If you go to test out Gemini now, the current version of Gemini, it can precisely tell you this year is 2024. Okay. If you ask what is the latest net profit of year 2023, it will of course answer you. If you ask what is the latest net profit of Petronas, it will also answer you, because now it's smart enough to understand. Now it's year 2024, the latest result is always year 2023. But it may not be as smart as if your financial year starts somewhere in the middle, right? That's another issue that we have not resolved. But then that is actually part of your work to do the grounding works to make it understand the context. Okay. So, and of course, most importantly is to connect the answer to the source. Okay. Like, I think you have pretty much see a lot of example of chatbot talking about customer services and all this. So what if I can connect the chatbot into the customer database, knowing what the customer expenditure patterns, and based on the buying patterns, okay, you basically recommend what are the good things to buy for the customers, for example. So Vertex AI is giving you this comprehensive grounding solution. First, based on Google search that give you the latest information. All right. It also gives you the access to the private knowledge connecting to your data. This is BQ, your MySQL, and so on. Of course, that also inclusive of unstructured data, your PDF files and all this. Okay. But now, because the other CAN, when I say the other CAN means the GPT CAN, has started the techniques of what we call RAG. Okay, RAG means chunking, caning, and all this lah. Why they have to do chunking? Because they cannot accept 1 million token like Gemini. So that's why when they upload a source file, they have to cut the files. That's the process called chunking. Once they chunk it, they embed it. Once they embed it, they have to chain it. So that's what we call the RAG process, which is not initially available in Google platform because Google has a no-code platform for RAG. Okay, we call it search and conversation, meaning saying that you just need to point Google to the data source. We will do the whole indexing process for you because we are a search engine. So we have the capabilities to do that. But because of knowing that the enterprise already started the RAG methods, we are now also open up the RAG API for you to use. And of course, that comes with a reasoning engine also, okay, to help you to call relate. And of course, with all these things, the last part is to let you do the RAG validation, which is what we call grounding check. Okay, to make sure that the answer is factful enough according to the customers. Now, so LLM can make things up, already show you, right? And can harm the user trust, already harm me, right? Okay, I mean, this always happens since last year already. This is something that we have to deal with day by day. Okay, and LLM also need to be trained a lot in the niche area of the knowledge, especially industrial knowledge. That's where, again, when you have all this requirement, that's where grounding kicks in. Now, so Gemini is here with the multimodal, with sophisticated reasoning, advanced coding, Now, grounding is the part. Now, if you have played with Gemini, whether on the Vertex AI context or even the Google Workspace context, you'll notice that now they have a grounding options, allow you to point to either Google search, or you can point to your customized data source, like your BigQuery, your Vertex data stores, for example. So that's where it allows you to link to the linking here. Now, customer building Gen AI apps on the cloud's Vertex LLM API. Okay, I think this one you will try. You need to try to understand it, how this works. Okay. One more thing is Google always emphasizes the explainable answer, because people say the LLM is a black box. I think recently my management made a joke on the GPT COO or CEO. Oh, they say that they don't know how the answer comes out. So Google is very proud of one thing, is that our AI is not a black box, gray lah, because we are always able to show you where the answers come from. Okay, I will show you how Gemini works later on. When you ask the questions, we can actually trace the fact of the answers. And of course, it is able to provide you a range of different perspectives. So I also can show you how I become an expert in an area where I'm actually not an expert. Okay, I'll show you how. Okay, so this is another example. Who win the Oscar of Best Actress this year? So this particular subjective wording called this year will give you an answer, for example, on 2023. Right? But then when you do the grounding, you will notice that, okay, this is the actual source. 2024, the best actress of Oscar is Emma Stone. Okay, another example of grounding. Okay, so now it's like the actual customer use case. For example, why grounding is important for example, Uber Eats, right? Because you have a chatbot, okay, you recommend the customer what's to order. The customer don't know what is biryani, right? What is biryani? So chatbot will tell them what's biryani, what are the different types of biryani, what are the recommendations and so on. So that's where grounding is very important, right? Unless you don't want the customer search about laksa. So laksa is a very good joke in Malaysia is like the Penang Laksa is not equivalent to the Riau Laksa and the Johor Laksa. Right? So I think that will be a big thing for Gemini to understand what is Laksa. But again, you can ground it, you can teach it. So this is another example. Quora, a platform for developers to build and share the chatbots. Okay. So again, grounding basically allows you to link to your data set. Now, so with the grounding features building in under the Vertex AI search, now it comes with the reasoning engine and also the IIG API. I will show you how to get some example code of IIG later on. Okay, and of course, with the reasoning engine, now you can use LangChain in Vertex. Okay, then of course, you can use different range of agent, and you have full control now. Because people always commented about the Google platform that they don't have full control about our Gemini builds, because they can't configure, they can't change this and that. Well, it's true. Okay. Then, of course, the RAG API to allow you to fully customize your data, your fact, your data source, okay, and basically help you to secure your data stores. And most importantly, is out of the box. Okay, and one thing is when you see in private preview, technically you won't find in your console. Okay, so I think you will only see this in probably Q3 or Q4. Okay, so grounded generation. In fact, grounded generation API is not yet available for you guys. Okay, so that's where I have a piece of source code that show you how to do grounding, but it's actually will not work if your account is not in the whitelisted preview list. Okay, but then the function is already there. Okay, so purpose of course is to reduce hallucination. So this is roughly how it looks like. I think it's a bit glaring, but you're basically setting the context now by specifying the source. All right. For the builder grounding example, wrap up. Okay, now. Always try to show you something colorful rather than the black and white slides with a lot of coding, right? Because end of day, you think that you like this, you can come to me and we can co-sell it together, or you can copy it together. Okay, so I just give you a context. What am I showing you? This is a sustainability dashboard. Technically, I'm pretty sure you heard about carbon footprint. Google always tell you we are carbon neutral 2017, carbon net carbon zero by 2030. Yeah, those are the story, right? So how do you visualize the carbon performance, okay, of a company? So for example, what I'm doing now is that I have a dashboard to show the carbon footprint of a manufacturing company, a car manufacturing company. Of course, what you see here is that there's water consumption, the recycling, the waste, electrical consumption, the emission, and so on. Okay, and each of these have the scoring, the weightage to give you the carbon index of 70. Okay. Then of course, there's an example of the pressing plants with an example of the visual AI, to showcase what is actually happening on the ground. Okay, now I have Gen AI telling me that based on my data, my water usage has been increased by 400% for the past 3 days. Okay, so what you should do, raise an investigation, and it will help you to save the money, save the water consumption. But again, this is just a showcase to the bosses, how things is possible with Gemini. Then in the welding plants, so again, where's the electricity consumption, the waste, and all this? Okay. So you say, hey, Wei Chung, this is analytics only, right? A little bit of Gen AI. What are you trying to show me? Yeah, what I'm trying to show you is, let me jump straight to the point. Right. Now, you have these reports talking about air transport, right? Talking about the margin percentage is 55%. Your logistic usually take 2.4 days to arrive. And this is the forecast impact. Okay, when it comes to maritime, What's the margin percentage? It takes slightly longer. What is the forecast? Now, as you, not a logistic expert, me neither, how do you interpret this graph? Which one better? Which one, what kind of things that you should improve? You don't know, right? When you don't know, you ask Gemini. Okay. So how this will work, in the first place, you have to ground the data facts to Gemini to make sure that Gemini understand the context of the logistic terms about air transport and maritime. Okay. Now it gives an interpretation of the air transport is more expensive, but it's faster, but it generates more emission. Okay. What are the next steps that you should be doing? Okay. Then it says that the KPI represents that the average days in transit for air transport method is actually lower, but it actually produces more CO2. Then the average days in transit for air transit is about 2.5 days. So it gives you a good summary of readout about the results. You say that, hey, what's so big deal about this, right? When I present this to some of the big enterprises, especially the C levels, they like it so much. Because always they will ask for a report. The staff will say, boss, give me 2 weeks, yeah, I compile for you. So with these two, technically, the boss will just need to ask 1 or 2 simple questions. Immediately, the boss will get the outlook and the answer. Okay? And now as a programmer for the ground, what are you doing now is that you need to basically connect your data source to Gemini. And technically, you have to define the metadata of it. Then Gemini will help you to tell different stories. Okay. Now, a different example. So this is another logistic example in the Taiwan Straits. So again, we can leverage on Gemini to basically elaborate the context. So similarly, you will see that it analyzes how the air transport performing, how the land performing. And you will notice one thing, right? It always compare about 2 things only. It talk about how long the logistic, the goods is actually takes to transit. What is the margin? And the next thing is talk about the carbon footprint. Do you notice that? Gemini only talks about these 3 things. Why? Because you ground it already. Otherwise, Gemini will tell you grandmother's story, right? Because you ground it already, you basically guide Gemini only respond in these 3 contexts and only analyze in these 3 contexts. Okay. So how to do this prompt in English? Just tell Gemini, please only analyze in terms of margin level, the number of days that it takes, and CO2 emission. By instructions, I show you how to do that. Now, of course, well, this one another chunky one. This is a Google Office US. I haven't been there before. So as you know that we have Google Earth, we have Google Map, we have something called the Solar API. What's so big deal about Solar API now? It will tell you how many solar panels that you put on your rooftop and how many electricity that you can generate. So this is an example. If I cover the whole Google campus with solar panel, that is the amount of energy that I can generate and the amount of saving, $9.6 million. I'm going to call my CEO tonight. They put all the solar panels. This is an example only, yeah, bro. Don't take it so serious, yeah. But what I'm trying to tell you is that Solar API is actually available even in Malaysia, some part of Malaysia, especially the industrial zone, in Northern Perak, in Penang, some part of Shah Alam is already covered. So it will slowly cover most of the area. Okay, so we're also working with some of the developers in the country to push out the solar initiatives. Okay, because you know that Google is building a data center here, Microsoft here, Amazon, Nvidia, you name it. I do my own calculation. I think there are about 6 or 7 data centers being announced in the past 1 month time. The next immediate question is, Tenaga Nasional, you ada electricity ke cukup ke tidak? No, that's the first question we ask. So we want to make sure that TMB also well aware that, hey, you know, with all this megawatt data center comes in, or even gigawatt scale data center coming in, do you have enough electricity? But one of my customers actually even asked me, it's not all about electricity, it's about clean energy, right? So you notice that I'm talking about carbon footprint here. the one big thing about the carbon footprint is actually not about how much I consume. It's actually how much of the energy variety that I'm consuming are solar, are hydro, are nuclear, or gas, and others. Okay, because Google say 2030 we are going to achieve net zero, and Google is going to build a mega scale data center in Malaysia. And if the Tenaga Nasional don't have enough solar or wind energy for us, there's no way we can offset the data center. And there's no way Google can make net zero by 2030, right? So the RE will become a big conversation for the next few years. So when I showed this dashboard to two customers, immediately the CEO said, "Can sell to me already?" I said, can. But you know that it is demo, yeah? But I'm selling the concept. Okay. The last part, just a bit of sharing. So what if I have all these energy waste measures, right? I got the index, for example, 83%. Okay, I measure the water consumption, the vegetation, the renewable energies, and the logistics. Okay, it gives me a net carbon credit of 391,000. Okay, I think a lot of people in Malaysia doesn't really understand what carbon credit is. Can I spend it? Can I use it? Or just to report it in Bursa Malaysia report, make sure that I'm green, right? You may be having these questions, right? What carbon credit can be used? Then I think our PMX also announced, or MITI actually announced about the carbon exchange. Allows you to buy carbon credit. Of course, allow you to sell also, right? But what is all this thing means? So now I'm crafting you a storyline. As a CFO of the company, I know that I have 391,000 of carbon credits on hand. What can I do with it? So I asked Gemini, "Hey Gemini, help me to spend my money, assuming that this credit is money." Take very long time. Network issue. Okay. Yeah, network issue, not Gemini issue. Generating name with Python 2. Okay, now, if you know the carbon credit world enough, right, you will notice that there's a lot of charities around the world, non-profit organizations actually accept carbon credits as an input for their activities like reforestation, right? If you go to the carbon exchange of Singapore, you can see that they have some reforestation project that produce 8,000 carbon credits a year. Those are the good example. So with the excessive carbon credits that you save in your company, you can technically give it back to the environment, to the communities. By example, to basically donate the carbon credit back to them. That's basically how do you achieve your CSR and also the carbon initiatives from your company itself. All right. So again, this is nothing much to do with the IAG accounting thingy, but just a matter of sharing how this can be sold in a much bigger picture. We are all salesmen, right? Yeah. Now, back to the grounding conversation. I know I only take 30 minutes today. Yeah, I need to burn some of your time. Okay. Let me share this. Okay, let's come back to the Gemini part. Yeah. If you have Gemini access, you'll notice that there's something called gems or germs. I don't know how to pronounce that. But technically, it's a persona setup. GPT don't have yet. Google one, this one, original from us. So each of these persona basically set the ground of the chatbot to the persona so that it answers questions accordingly. For example, as a learning coach. Okay, I give you an example. Brainstormers. Okay. What I'm going to show you now is, okay, so this is a real example. I go to a customer place, they're doing media, TV station. Then they tell me, "Hey, Wei Chung, I want to use Gemini to do summarization and translation of the video and the movie." You probably know either RTM, Media Prima, or Astro. Either one of these are asking me these questions. But I said, bro, I'm not the expert in the media. How would I know that? How to help you, right? Then he said, I don't care lah. You Google, you figure it out yourself lah. Okay, so I have to figure out myself. Now, I want to generate subtitle for the videos. As a specialist in the media industry, I need to generate subtitle based on videos. Okay, you say that what are other things that you can write? Because prompt engineering is all about prompt, right? But this is as much as I know how to prompt. Never mind. Gemini help me to prompt. Not bad, right? So as a specialist in the media industry, I need to generate subtitle based on the video. I would like to know the best practices and tools to use to generate the subtitle generation, and if there are any legal considerations I should be aware of. Gemini helped me to generate my prompt. And I run the prompt. I become the media expert going back to my customers and say, is this good enough? They say, yes, better than I know. Correct? So that's why I say, you just need to learn how to use the tool. Right? So you want to generate the subtitle, you have to prioritize on the accuracy, the timing, synchronization, and the proofread and all this. Okay? And it also tell you the tools for the subtitle generation, the legal consideration, additional tips. Now, the small g here, right? Fact checking, or what we call grounding, or explainable AI. We have a lot of marketing terms for it, okay? Preparing results. What is trying to tell you that, brother, I'm not simply say one, all got source one, you see. So quoting you the source. So you may be asking, what about the points that doesn't have the highlighters? Those are what it makes up by itself, right? All right. But it's still true as a context of the media experts. So this is an example of grounding. Even on the consumer grade of Gemini. Okay, now, hang on. Okay, let me reshare my screen. Window. Okay. My lovely GCP console with Vertex AI. Okay. Okay. Now I go to multimodal. Google always emphasize about our multimodal because my model can read video, sound, anything. Okay. We read a lot of things. Now, with the multimodal, what we can do is, for example, I can insert a media. Let me see if I still have the same prompt. Hang on, wave files. Okay. I think I have showcased some of you guys these wave files in my last sessions. So what happened is that this is a customer service recording with My2Car. That is what we have done for them.
We are connecting you to customers.
Real one.
Hello.
Hello, hi, Encik Farid. Saya Amrita dari My2Car.
Okay, alright.
Saya nak confirmkan appointment you 29 hari bulan di Taman Sentosa. Confirm boleh datang?
Taman Sentosa kan? Boleh?
Betul.
Sebab dekat sikit dengan rumah.
Okay, so nanti cik, masa cik dah sampai ke branch kami, Untuk inspection ambil masa dalam 30 hingga 45 minit saja. Lepas dah inspect nanti, cik akan dapat harga dalam tempoh 24 jam ya.
Boleh?
Boleh ya? Okey. So nanti cik, untuk next proses saya akan hantar dekat WhatsApp cik. Apa-apa cik tak clear, cik boleh inform saya dekat WhatsApp lah.
Okey, boleh.
Okey. By the way cik, untuk keretanya ada grant tak cik?
Ada, semua ada.
So nanti make sure saya buy grant masa inspect kereta ya.
Okey, boleh? Alright.
Okey. Terima kasih.
Okey, sama.
Okey.
Okay, sama-sama. So help me to transcribe the customer conversation in dialogue format. Help me to evaluate the sentiment of the customers. All right. Submit. Okay. Now you see the response was blocked because of an unknown reason. I know why. It's because of the language filter that we have set here. Because what happened is that if the customer's conversation has some tricky words or letters, then it will block. Okay. So of course, there's supposed to be a block none options here, but it's only available and open up for some special group of customers. So we can only set to block field. Okay. So this is, I mean, a known issue already lah. And then sometimes it works, sometimes it doesn't work. We already report this as a bug. Okay, let me change to Gemini Pro and see. You still block me, yeah? All right. Use ChatGPT. Well, ChatGPT cannot accept the sound. Okay. That one you can give it a try. Okay. It's still blocked. Never mind. Give up already. Okay, what I'm trying to show you is actually, even though the front end is blocking you, you can basically still run this at the back end. The back end will not block you, like me in short. So you say that, hey, Richard, I don't know how to do this in backend. In fact, right? So what you can do is that you go to the get code, whereby you have a Node.js example, you have a Java example, you can even do it in the command curl, or you can do it in Python. Okay. So what you need to do is just go set up a Jupyter notebook, for example, run the script. It will give you the transcription, the sentiment analysis, and all this. Now, I don't like to showcase this demo anymore. Every time not working on. But last time when I show you, it works. Yeah. Let me give a last round. Asia, Singapore. Is orange. China. I like this. Okay, let's try one more time. It's still blocked. Never mind. It's about. It doesn't work towards today's demo. Okay, unfortunately. Okay, so the last thing I want to share with you is that if you go to GitHub, and you search for GCP Gemini, what you will notice that you have a series of generative AI lab, and there's a Gemini folder here. Then Gemini grounding, yes. So this is a sample code of grounding. So what it does is that it just connect to the Gemini model. Basically, you just key in the prompt. But what happens is that at the bottom, it's basically help you to ground it to a private. Hang on now. Okay, it helps you to connect to a Vertex data store. and you ground it with the data stores. Meaning saying that it doesn't connect to the internet world or the general knowledge to answer questions, but it answers the questions based on the data stores information. Okay, so how this data store will normally look like? So the one that I had here is, continue. Yeah, so I have a weather data here. It's actually a BigQuery data. So what happened is that you just connect the data store to BigQuery. And what you need to do also, the next thing is that you have to do a metadata definitions on all the field. Make it as a Vertex data store. So it can be one of the grounding source already. All right. So if you go back to the multimodal example, right? You will notice that also here, which now they enable you to include the grounding source as well. And you can point to a Google search or a customized database. All right. Which then eventually your whatever you do here will be related to your private data sets. Okay. So this is all the grounding all about. Okay. I mean, like again, in layman is just technically so to make sure that your performance of the Gemini doesn't go viral. Everything in control. Okay. So I think that's all I want to show you all today. So I hope that this language thing will be fixed ASAP. Yeah, because it gave us a headache. And yeah, that's all.
Thank you, Wei Chung, for the
Thank
sharing. Right now, we are supposed to be moving on our second talk by Amrita, but because Amrita is preparing the lunch for us, so we will replace with the last talk right here, Build Your Own Redis. This will be shared by Hairizuan. He is a DevOps engineer at Kiteworks. So let's welcome him.
Yes. So I get me to share, right?
Have to join the meet.
Okay.
This was
This one. This one.
because the mic.
So yeah, I just
Yeah, so
join. Ooh, okay. Oh, so I don't need to connect.
there.
Oh,
No, next one.
yeah, just entire screen. So it's actually okay already. Can already. Okay.
See,
Oh, just comment.
or we can use this.
Okay. I mean, I need to do demo lah, so probably might use this mic.
But mine will be here.
Okay. Hello, hello. Okay. Yeah, this podium is actually quite short. Oh else. Okay. Yeah, so this one will be one of those few like non-AI topics for the day. Yeah. So I don't know, like quick question, just out of curiosity. Who here is tired of AI content? Wow. Okay. Nice. There are like-minded people like me. Okay. So, okay. Review non-AI technical content today. Build your own Redis. So a quick. So let's first start things off with a bit of myself. I'm from Singapore. One of the GDEs from there. GDG, GDE Cloud. I also help to organize the Google Cloud events there as well. So if any of you are interested, maybe you have some spare time, can come down to our lovely island in Singapore to go and check things out there. there are even Google Cloud events there as well. I think end of the year there will also be that major DevFest event. So I'm predicting this year will be quite big over there. So that's the thing. I'm also author of a book that's not really selling that well. So, um, I'm just going to put a link here. I'm not saying that you want to go and click and take a look, but yeah. Okay. All good. Okay. So next part. So first things first, why build your own Redis? Technically, that doesn't really make sense. Like usually, you wouldn't want to do this. But yeah, let's say if you really do want to go down that path, like why? The first question you should ask yourself is like why? Because normally you shouldn't, because Redis itself is a pretty complicated product. And I mean later I will show things on why it's kind of complicated. But yeah, let's say you throw all those reasons aside, like why would you want to do that? So one of the reasons is the first one, for fun. You just want to torture yourself. But also like you know, like as time goes by, like let's say if you are a software developer in those big major companies, what the first thing they will keep throwing at you is build this crap app, build that crap app, and then eventually you get tired. It's just like REST API backend with a database with a cache over and over again. It gets tiring. So why not, if you have time, explore on how these kind of things can be done. So I think if you go online, there is this thing about um, like build your own X or something. Like the X can be anything. So Redis is one of them. You can build your own database. I think online also there's some guy that say build your own compiler, build your own virtual machine. Like there's those kinds of levels. So this what I intend to do is just like this build your own series, right? This is like one of the first few I'm going to give a talk about. Maybe in future there'll be future sessions, and maybe it might be good if you want to go and take a look and see how this kind of thing can be done. So that's reason number one. Reason number two is maybe you have a particular set of issues that you don't like with the current Redis. Current Redis is not perfect. If I'm not wrong, there is the issue where maybe Redis doesn't do clustering that well. There is a solution for it, but it's not perfect. Maybe you don't like that the way they approach it. Maybe you feel like you can do a better job at it. Yeah, so then you definitely will have to go down this path. Or like the third reason, which is very unlikely because no, most companies wouldn't do this. Your company tells you go build a new Redis because we don't like the Redis out there. And a reason for that could be because of the recent license change. So who here have heard of this thing happening? Oh, okay. I guess it's not that big of a deal, I suppose. But yeah, so apparently because of this license change, I think it affects more of the bigger players rather than like the normal software developers like you and I. I think the majority reason for this is to prevent like the bigger cloud players to simply take Redis and just sell it as it is as a solution. So that's my guess. But yeah, let's say if it's really that the license change is the issue, then your company tells you to build, then yeah, you have to go and roll up your sleeve and start building one or something. There are other Redises out there, in case you are curious. So I think right now the up and coming Redis implementation that people keep coming up, keep mentioning over and over again is this Redis called Valky that is said to replace Redis. That they say they want to replace Redis because they are more open in a sense. But I don't know. And also there's another Redis solution. Because apparently some people want Redis, but they don't want. They want Redis, but they don't mind a slower Redis. They say it's too fast. So they don't mind they don't mind a slow Redis. They want Redis with persistence. They want the data that is stored on Redis to be even if you switch off the machine and switch it on again, the data is still there. So there is that second link. If you want, you can take a look at that repo. But yeah, I'm not going to go through these two products because they are really quite complicated at this point. Okay, let's go to the actual topic. First thing first, like how do you actually communicate with Redis? So as software developers, most of us would just simply connect with Redis via a library. But how the library works, we don't generally need to care too much. Because the library implementation should take care of all those things. Like making sure that the data is being sent properly. They have the proper connection pools, etc. So it's assumed that everything is done right. But if we go under the hood, then if we check on the Redis website, there is this thing. Let me go to this link here. So if you go to check Redis website, there is this commands page. And then if you look at it, just like, okay, what the heck is all this about? Like, these commands are there. How do you exactly use it? So if you check around on the Redis website, apparently you can communicate with a Redis container, not by a library or anything, but using NC or Telnet. So let me quickly do a demo for that. Okay, let me close this. Okay, hold on. Okay, is it big enough or people? Okay. Blinds are closing. Okay. People at the back can see or need bigger? Okay. Bigger a bit. Okay. Oh, okay, maybe too big. Yeah. Okay, so first things first, we're going to start a Redis container. I'm going to shut this down first. Docker. This. Clear. Everyone here kind of familiar with Docker, right? Okay. So let's start it. Huh? It's possible. There are libraries out there. I think there is this library called Containerd. That's one of the things that you might need to look at. And then I think under the Mobi family or something, yeah, you can, but it's really hard. I think there's a talk also by Lara Liz Rice, I think. If I'm not wrong. Okay, a quick tangent here. Okay, let's go quickly to YouTube about Liz Rice build your own container. Yeah, postdoc. You can just follow her. Apparently, you can write your own container that does what a container does in 20 to 25 lines of code, but it doesn't have any of the nice things that Docker provides you. It doesn't have Docker Docker file. It doesn't know what the heck is a Docker file. You have to write an interpreter for it, etc. So yeah, if you're interested, a bit of attention to whatever I'm trying to talk to, but yeah, if you're interested in that. Okay, let's go back to this. We will run a Redis Docker command, a Redis Docker. We need to expose it if the default Redis pod. if demonized Redis status. Okay, so that should work. All right. Okay. So with that, let me show how to quickly connect to this via NC or Telnet. So let's say if you just run Telnet localhost. So essentially before I did that, what I have here is now a Redis instance or Redis container that's running. I expose it locally, port 6379. There's a usual port for Redis. And then let's connect it via Telnet. Telnet, localhost 6379, should be no problem. And then it says, okay, connected, and then it just leaves us there. So what can you do with it? So one of the first commands that you want to check is, can you even connect to it? Like, what's the most easiest command that you can think of? And if you are dealing with machines day in, day out, the first thing you want to do, let's say if you're on a server, is to ping it. Redis has also a ping command. So let's ping it, and you reply with Fong. Okay, that's good. So we now have Telnet connection. We can ping it. It's replying something. So that means we are replying to Redis. Yes. Then the primary purpose of Redis is to temporarily store stuff in cache or something. Like it serves as a cache of sorts, right? So let's ask it to store a value. So let's put set xxx as 12, and then it just replies okay. So set. Then the next step definitely would be to get xxx, and we get a return back to 12. Okay, so that means we are dealing with actual Redis, and this is kind of how you would interact with Redis via Telnet. Okay, let's go back to the slides. So far, any questions? What? Okay.
Very new to Redis.
Yeah.
So where does the cache actually store that?
For Redis, by default, it's stored in memory. Yeah, that's why Redis is so fast. So okay, there's when it comes to computing, there's the different levels of speed, right? So anything that you say you store on disk is slow, immediately very slow. So that's why if you go to those bigger companies, when it comes to scaling, one of the primary things that companies have problem scaling is databases. Databases are just so slow because everything is stored on disk. Everything has to be flushed to disk. Like flush means like written down to disk or something. So reading and writing to this takes a while. So anything that's stored on memory is very, very fast. That's why Redis is lightning speed, in a sense. You can consider it the same, like let's say if you are talking about all those, even those big data technologies, there's this Hadoop as well as Spark. So they kind of are similar in concepts. Hadoop flushes things down to disk, while Spark mostly deal with memory. So that's why Spark is so much faster than Hadoop. It's not because the code that the Spark developers write is faster. It's just that inherently they are dealing with a faster medium of storage. It's just that with Redis, if everything is only stored in memory, once you turn off the machine, you turn it on again, all things are gone. While for, let's say, I think if I'm not wrong, Redis does have persistent mode. You can do that, but then I think in the documentation, they will clearly say Redis will slow down once you do that. To answer your question?
Yeah.
Okay. Any other questions? All good? Okay. Okay, next part. So I have a quick code base written with Golang. So with regards to this, so in general you would normally know how to use it, but this is mostly done so that we can do we can properly do the exercise later. We can properly show that with that same code base, with the same Redis library, we can interact with our fake Redis implementation that I'll be showing later. So if you want, you can take a look at the code base. Nothing much. Let me quickly show it. Okay, I'll give another few seconds. Okay, all good. All good. Where are you? Where are you? Where? Give me a moment. Let me go to that place. Where basic Redis. Okay, if you click on that link just now, or you scan the link just now, it will bring you to this GitHub page. And it's basically a few simple things. Like, let's say even if you are not that familiar with Go, let me quickly explain to you how this code kind of does it. So we're importing the Redis library. On top bit from line 19 to 24, that is a set command. We are doing a set. Line 26 to 27, we are just doing a ping. And then line 29 to 33, we are doing a get. So just basically that. So let me quickly run it just to show that this code works with actual Redis. So let's go back here. I'll leave the Redis on. Let me quit the telnet session. Okay, let me go to the other page. Okay, cd web basic Redis. Okay, what I'm going to do is just simply to run it. And it will produce. Oh, okay, sorry, wrong port. Give me a moment. Let me change that. Basic Redis. Okay. Clear this, and then we're just simply going to run the script. Nothing too crazy. This is kind of the output. So whatever fake implementation that we're going to do, when we run this same main Go script, it should produce the same output. But okay, let's take a step back, and then first things first, when we build our fake implementation, we will need to also connect it via telnet to prove that the whole thing is working as expected. So yeah, let me go back to the slides. Okay, so there's a few things that we're going to replicate here. So now we know a few things about Redis. So for Redis, the Redis, what we communicate with it is just plain old text strings. So we just send text like a ping, that text in textual format, plain string format. We send it over, and it will respond accordingly, based on all the Redis command, that Redis commands page. And in order for us to get the main.go working, we'll need to implement this set of commands: ping command, get command, set command. Okay, so I'm going to quickly go through how we can implement it in Go, responding to ping, etc. So this is for responding to a ping command via Golang for when we are building our fixed server. This is kind of what we need to implement. Okay, let me quickly show one thing. So for each of the programming languages, I guess I didn't cover this in the slides, but I think this is kind of important to cover. For each of the programming languages, instead of dealing with the usual client server thing, we are technically building something from scratch. So we actually will be communicating with a socket. And where was that socket? Let me see, where is the socket here? So for Golang, this is kind of how you will start the socket here. Net.listen. I'm not sure about other programming languages. Other programming languages have their own particular ways on how to deal with socket. But for Golang, this is the one primary line. You set that up. Basically, it opens up a socket there. A TCP connection. It will accept TCP connections, and it will be opened up on port 9999. Then from there, we will interact with the socket by reading off and on it. Because we're not dealing with bytes, it's way easier. We can just accept it as plain string, convert the bytes out of that, whatever that's coming through that connection to string, and then parse it. And that's where we will lead back to the slides just now, where I just like, if the command is equal to ping or whatever. So essentially, whatever thing that we accept from the command, we just run this command, run this like scanner.txt to just retrieve it. Basically, it's kind of standard in a sense. For Golang, this is kind of the way to do it. Other languages have their own particular ways of how to read stuff from off the socket. So this is like step one, in a sense. Once you have all these steps, essentially now you're accepting some sort of input, and you can parse the input and build off your server off that. Any questions so far? All good? Okay, yeah. So the TLDR of all that, use a socket to retrieve your inputs, your incoming inputs. Okay, so once you have your input, what do you do with it? First things first, your input will be coming in as string. And essentially, what I did here was I put the first item of that string. Like I'll break up that string into multiple bits, into multiple pieces via the split command, via split by space. And then the first one will usually be the command. So like just now when you use the word set, set is the first thing, first word in that line. So that's usually the case. So in this case, I set that as the name, as the command that we'll be dealing with. So for ping, it's kind of easy. We just when we receive the command ping, reply Fong. That's not too major. For set, it's a bit complicated. If you check the Redis commands, you will see this whole line of things that that can be provided to the set command on official Redis. It seems a bit too complicated. Just now when I was showing you the set command, I just showed like three items only: set, xxx, 12. Technically, that's enough to get things going. For our implementation here, I'm not too bothered to implement the rest. So I'm going to cheat my way through. I'm just going to ignore all arguments that come after that. And then, yeah, so I'm going to just follow what the Golang library kind of wants. So for the Redis set command, what they only wanted was key value, technically expiration, but then in our code, we can just ignore it in a sense. That's just to make our simple fake Redis easier to implement. So with that, with set command, we'll just say that if the number of inputs is less than 2, that's no go. We'll return an error. If input is more than 3, we just say that we'll ignore the third one, and that's kind of how we put it in. So and then as with Redis, we just reply with +OK. That's for set. Not too major. And then for get, kind of the same-ish. It's also quite it's also a simple command, so nothing multi-measure here. So for get, we only expect one argument, which is the key that we are going to get, and then we'll just return that key, and that's about it. One thing that we need to take note here is let me go back to the Redis telnet. Where are you? Here you go. So for Redis, is it telnet? No, I'll just run telnet here. Telnet localhost 6379. So for Redis, when we run a get command, we realize that it returns two things. First, it returns $2. So what that $2 essentially what it means is the length of whatever item that's going to come next. And then 12. So as an example, let's say if I set YYY as something like this, then if you get YYY, we'll get the corresponding output as so. So the length of the incoming string is 15. So we need to implement that as well, because apparently what we'll be interacting with is the Redis client. We're creating a fake server. This official Redis client will be interacting with it. We need to try to match the expected output as much as possible. So that's that. So combining all that, we can now have kind of a fake simple Redis implementation that does a ping, get, set minimally. And that's kind of sufficient for a very minimal Redis server. Let me quickly do that. Okay, let me build this first. Go build -o. And then let's run the server. Okay, now we have our Redis server running, our fake Redis server running. So instead of interacting with our actual Redis server, our official Redis server, now we interact with a fake Redis server, the one that we just implemented here. Oh, okay. I guess I forgot to share the link. So in case if you want to check the code base before we continue on with demo, you can scan the code here, scan the QR code here, and then you can see and follow along and see how the code kind of works, how ping, get and set functions are put into this fake Redis server. It's written in Golang, so feel free to rewrite it in your own programming language of choice. I think most programming languages have that same mechanism, like sockets and everything. So yeah. Okay, all good. Okay, let's go back. So based on the code that you see here on GitHub, I've run it already. I rebuilt the Golang binary and run it. So let's try to communicate with it. Telnet, localhost, and then in the code base, over here, in the socket connection is 9999. We'll connect to port 9999. And then, okay, so far so good. We are connecting with something. Let's ping it. Receive a pong. Very good. So that's step one. Next step is, can we put a variable and ask it to store something? Set TTT 12. We get okay. Then the next important one is, can we get our TTT back? Okay, so it works. We have a fake implementation of Redis with that whatever code base that you scan the QR code just now. So feel free to take that code, run it, but don't run it on production, please. Your boss will kill you for sure. Okay. Okay, next step. Now, what we want is to connect our Golang application tools that take Redis server. So how will that fare? So I'll leave this running. I'll leave the Redis server running. So it's getting some. I just printing out whatever commands that's coming in. So let's go to our. Is it this one? Let me see. Okay, this one. This is where we were having our main.go Redis client file, which does the set, ping, and get. Let's try to run it. Oh, sorry. I put it to the wrong server. Let me try again. So just now, the code is 6379. Let me switch over. Mind you, for this one, I am using the official Redis client. So no Golang interfaces or whatever. So it's using the same official Redis client to interact with that fake Redis implementation. So that's why making sure that the outputs is the same is very important here. Okay, let me save this and let me rerun it. I expect it to fail. Okay, so why is it failing? Okay, I don't know why the output is not coming out. Hold on. Let me clear this. Let me try again. Okay, hold on. I expected some logs to come out, but apparently it's not coming out. Okay, yeah, okay, this is what I expected. I don't know why it's not coming out just now. So, firstly, we are receiving an IO timeout. So, what's the reason for that? So the first thing first is if we have the logs properly come out, which it was weird that it wasn't. The first thing that we'll see is it's sending a hello command, and we don't have hello. So now we have to implement a hello. But how does hello work? If you check the documentation, it will just say it will print out a map of array or something of values, and that's too complicated to think about. So what we're going to do is we're going to bash our way through. We just say telnet localhost. Okay, let me clear this. Clear telnet localhost to our official Redis server. Redis server, please say what happens when I run this command hello tree, which is the one that we receive. Hello and tree. Okay, a bit of explanation for whatever that's here. Asterisk 2 essentially means how many items in a list you'll be the server will be receiving. Then $5 will be the length of string that will be sent over, and then hello will be the actual thing that you need to process. So this kind of how the Redis client is sending over. So all we need to do is we just take the hello and we just take the tree, and that's what is we need to process here. So for the official Redis server, let's send a hello tree, and this is what we need to implement in a sense. And it looks like a bunch of stuff. I'm not going to go over like the details of it. Essentially, what it returns is 7 items with a bunch of all key of stuff that kind of makes sense at the same time doesn't. So all I wanted to do is just have my Redis server working. So I basically just take this output and simply copy it into the Redis Alfix implementation. So if you see the hello.go enable hello command, this is basically kind of it. like everything I just put as string, just print it out. I'm pretty sure those things mean something to the Redis client, but for now, since we are not implementing a good Redis, a good fake Redis, this should be enough to get things working. Another thing that we will need to take note, if we go back to the logs, we will notice that it's passing in things one at a time. So just now, all this while when using Telnet, I'm just like typing something like this. Okay, let me bring this up. It Telnet. Oh wait, hold on. Let me bring this up first. Okay, Telnet. Okay, what we usually been doing all this while was something like this: set xxs 999, something like this. But how the Redis client actually does it is, we are going to send a set command. So we are going to do a $3 first, and then you see that Redis, the official Redis, doesn't send back anything. So it's actually expecting 3 incoming inputs. So we'll need to do a $3 set, then $2 XX, and then $3 999, something like that. This is what the Redis client is actually sending. So our fake Redis implementation also have to take into account this. We have to implement this. I'm not sure, but this totally feels like computer science assignment, and it brings back nightmares. So yeah, now then we get the okay. So we need to implement this as well. So that's why the code suddenly get a bit more complex. So that whole complexity is all in a perf here. I just call it an broken up commands. And in order to do the demo today, and in order to show this point, I put it behind a bool to enable or disable that feature. But all these details are all here. So feel free to parse and analyze the code, or you want to follow the advice of all our previous speaker, you can use Gemini, go and talk to it. Okay. So with that, I'm just going to enable this now. Let's say if we implemented it properly, we implemented the hello command. We implemented the broken up command. So basically, it's sending, instead of sending like hello tree in one string, it sends things one at a time. So once we implemented those, let me rebuild this. Quit. Go build. Quit. Oh, okay. I shouldn't have run quit. Go build. And then let's run the server. Okay, server is running with the feature enabled. Now let's go back here to our Redis. Let me clear this. So with those two particular problems out of the way, now technically this should work. Okay. Okay, so it works. So with that, our fake Redis implementation actually works. Actually, I just got it working last night. So yeah, I will applaud myself. Okay. Yeah. Any questions so far? All good? So what we have in that fake Redis implementation is now 4 commands. Get, set, ping, and hello. If you do get interested with this topic, you can proceed on to try out all the different other commands. I think there are some commands that might be interesting to look at, like lrange, mset, etc., etc. Those are way more complicated to implement. It's not sufficient. I mean, it's too complicated to show in a demo like today. But if you want to to like find out how you can go ahead with it, you can go and try to implement all those stuff out. Oh yeah, and did the hello command when we initially had the issue with it. So yep, let me skip that. Okay. What is this about? Okay, never mind. So a few things to take away from that is this Redis thing is one project that we can potentially do up. But what other possible projects to try out after this? So if you're just going to continue on with this Redis path and try to explore, how can you get like what are the other things that you can implement? So one of the other things is clustering. So as what we just now mentioned, Redis cluster is not a perfect solution. Maybe you think that you have a better solution out there. You can try to implement that. One of the things that you will definitely need to take a look at is the RAF protocol. RAF is in things like etcd, etc. You might want to see how those are implemented. Then maybe you can take all those libraries and implement it as well. And another thing that might be worth checking out is, let's say for Redis, initially Redis, everything is put into memory. Maybe you don't like that idea. You want your data to be persistent. You don't want to lose the data all the time. You can take a look at how you can store stuff. Even just now, the current the implementation in the fake Redis is also a very, very bad implementation. I used normal maps. I think, yeah, normal lists and map, and that is definitely an issue. Map is not concurrent, so if I happen to run it properly, if I have multiple Go routines calling into it, they will start to step over each other, and more issues will come up. And then if you try to run the data racer over on top of it, the Golang tooling will just say you have a potential data race issue, and the data race issue is definitely not one thing you want to have for a data product, which this is. So that's for the tool for the bottom bit. Other things that you might want to take a look at. Let's say Redis is too easy. I want to see what else out there. There is the Postgres SQL protocol. Essentially what you are sending over is bytes, and the bytes will contain commands on how to interact or how a query is to be interacted with on the server. So you can take a look at that. It's really, really complicated, and I thought like I could like take a look at it and maybe try to describe it in an easier way, but yeah, there's pages of documentation for it. The thing is, I'm thinking that maybe AlloyDB, which is done by Google Cloud, maybe is using that. Maybe they are rolling out their own Postgres. They rebuilt the whole Postgres protocol, but the thing is, I won't know. Maybe a Googler will know, but I don't see any Googlers here. No Googlers. Okay. Then another potential project that if you want to take a look at, build your own HTTP client and interact with the HTTP server without using the programming languages HTTP client. Like use plain socket text to send over. So these are the references to all the stuff that I've been mentioning just now. And yeah, that's it. Okay. Okay. Any questions? All good? Oh, okay.
What kind of concurrency methods did you use to implement a fake, more like concurrent fake Redis in Golang?
Okay, what kind of concurrency patterns you could implement in a fake Redis?
Does it support concurrency?
Yes.
Yeah.
Correct. So normal maps in Golang doesn't support. There is a concurrent map in Golang. It's a library in the core Golang library. You can potentially use that. Another way is you go the old way of doing things. You lock. Yeah, channels is the official way of doing it. The old way of doing things will be to lock things. You write the thing and then you unlock it or something. There's also another way. The official way that a lot of the coding people say is channels. Yeah. Any other questions? Or want to go for lunch really? Oh, okay. Okay. Well, what's your next question?
This is a really more to your DevOps role right now. Would you ever run a Redis instance in a sidecar container now that Kubernetes supports sidecar containers in 1.28?
No, I will not run it in a sidecar. I will run it as its own separate service.
So using an operator.
Yeah, potentially using an operator, but I haven't seen great like the operators keep coming and going, so that's a bit sad. I haven't seen a really good one. I think Bitnami could be the Bitnami Redis Helm chart operator could be a potential good target, but yeah, we can talk more after this. Yeah. Any further questions? Oh.
Just something aside, we don't know how to write tests for
How to run tests for concurrent code? That's a very good question. I don't have a particular good answer for that, because even now, my current company, they had a data race issue, and the data race issue happens like one every 100 times. So concurrency is really hard to reason about with. Basically, one of the things like maybe run the thing for quite a long time. Like some bigger companies, what they do is a soak test to see like as a long time goes, to see whether your data is still as expected. That could be one way. Golang's data race tool is definitely one tool that you can try to check out. Another way is, I'm not like I don't have a very good answer. Yeah, these are the two approaches that I would know of. Any other questions? All ready for lunch? Okay.
Thank you. Thank you, Hairizuan, for the sharing about Redis. Unfortunately, it's not lunchtime yet. There has been some delay in our lunch delivery, so we will be having lunch at 1 p.m. So during this time slot, we will have Amrita right here to share about large language model in BigQuery. She is our technical project manager in Southeast Asia, in Malaysia and Singapore, Google. Yep. So with that, we will welcome her for this session before our lunch. Yeah, stay with us. You share screen, right?
Yeah, shadow, but I think it's showing up.
Yeah.
Okay. Thank you. Well, hello everyone. So thank you for joining us today. And are you all still good, or are you hungry already? Sorry about that. I'm hoping that my talk would do the magic and the food would arrive sooner. And I'll try to keep you all entertained meanwhile while waiting for our food. So our food would arrive by 12-ish, so hopefully not by 1. So don't worry about that. So we'll try to make sure that it arrives by 12:30 latest. But till then, I hope all of you are still okay to go through this. Yeah? Yes? Okay. All right. Awesome. Okay. So yeah, thanks again, Sammy, for the introduction. I'm Amrita. I manage our communities in Singapore and Malaysia. So I'm also a technical project manager for our Southeast Asia developer programs at Google. So before I get started, quick question. How many of you here joining our GDG Cloud event for the first time? Show of hands. Okay, cool. And how many of you are hearing about Gemini and all for the first time? So I know we've had a couple of sessions before this as well, and some of our speakers have already talked about Gemini. So anyone hearing the term Gemini for the first time? Okay, great. Good to know that. Okay. All right. So for today's session, I would be talking about using large language models in BigQuery and how it can help you with your data journey. As you know, for instance, if you're a data engineer or you're working in the data ops for part of the work and all. So the last time we had a session over here, I had a quick question. How many of you here are data engineers? And last time I asked this, I didn't have anyone in the room. So today, do we have any data engineers here? Show of hands. Okay, no worries. Yeah, so for today's session, it's going to be relevant to most of you here if you're working with data in general. So even if you're a data engineer or data scientist or analyst, regardless, it would be hopefully it would be beneficial for all of you. So I'll be walking through how you could use BigQuery, even if you're someone with only some SQL background, if you haven't done traditional ML engineering techniques before, but you would like to jump into it. So I'll be covering how you could use BigQuery to potentially start working on the ML application, even if you've only worked on SQL before this. Okay, so yeah. So these are some things that we'll be covering today. So I'll be covering a little on Gen AI and BigQuery, and we'll talk about how BigQuery is this unified data platform for us now, and all the new features that we have with Gemini and BigQuery brought together, right? So the integration of Gemini and BigQuery. And we'll also be talking a little about the vector embedding generation and also vector search. And I'll quickly run through a use case used by one of our customers, Unilever, on how they use the BigQuery platform with Gen AI. Okay, so I know now all of us are super excited about the entire thing of the AI era, right? So at Google we call it the Gemini era now, because right now we have Gemini integrated in pretty much all different products that we have, whether it's like the consumer products or in general, like for instance like Android or search and so on, right? Or if you're using developer products as well. So now pretty much everything has Gemini integrated in it as well, right? So quick question, how many of you feel that Gemini or AI has already become a part of your lives already? Show of hands. Okay, so fun fact, for the rest of you who didn't raise your hand, right? Sorry to break this to you, but I'm pretty sure Gemini is already a part of your life. So how many of you use Gmail, for instance? Can I see a show of hands? Okay. And okay, if you're using Gmail, when you type out your email, like when you draft it, do you notice the suggestions that are provided to you to complete your sentences? Yeah, so that's how AI is being integrated, right? To support you with your daily tasks. For instance, writing emails, it can be a bit tedious and sometimes it takes up a lot of time, right? And with all these suggestions, it sort of helps us write faster. And how many of you have already started using Gemini to like ask questions and stuff? ChatGPT? Okay, so yeah, so for me personally, my day-to-day tasks involves a lot of having to draft out emails and sending out reports and so on, right? And there are days where I feel like having to type things out from scratch, writing things out from scratch, it takes up a lot of time. And to make things more efficient, I would just prompt it, like I would say, like, this is what I want, and I would get a draft. And based on that, I would, of course, rephrase it and make it the way I would want it to sound, right? So yeah, which is why I was saying that we're in this era where everyone is trying to get into AI. But the thing is, when it comes to companies using it for their development itself, I know a lot of companies now are trying to adopt, and they're trying to integrate into their existing systems. But unfortunately, from what we've seen is that only about 19% of companies actually excel at maximizing the value from data. For instance, using AI and so on, right? The thing is, we have a lot of insights that can be derived from all the data that we have. But the thing is, there are a lot of limitations with the traditional methods that we have, right? So for instance, we have all these unstructured data, which sometimes can't be really used because they haven't been cleaned up well, or it hasn't been, stored in, for instance, it has been stored in like many different silos. For instance, like each team would have their own set of data, and it's not being shared across, right? And there isn't a unified platform for everyone to, tap into it and make sure. I mean, of course, when you tap into it, you've got to make sure that only those who have access. I mean, for instance, like it has to be people who are relevant who get access to these data that you have. But the thing is, even within a team, there are many smaller teams, right? And different teams would have different types of data that's with them. But if we bring it all together, we unify it, it would be able to give us even more meaningful insights. There may be a lot of things that we would be able to tap into as well, right? And yeah, so what we want to do is we want to make sure that we have this unified platform to not only manage the data well. So for instance, if we want to use both structured and unstructured data at the same time for a particular project, we want to be able to do that. And we want to make sure that all these little islands of data that's everywhere, which sometimes could not really make sense if they're put separately. So we want to make sure that we sort of like stitch them all together so that we get to see and we get to connect these things to see what could possibly come out of it, right? And yeah, and finally, we want to make sure that all these, I mean, all these organizations who are using this, they don't have to end up spending all these resources and like all the time that they have on just trying to patch things up together, right? And what we'll want to do is this unified platform should be able to manage all these things at the same time. Security, data governance, and all that isn't being impacted as well. Okay. So the good thing about this is that at Google, we've been taking upon this challenge to make sure that AI is a part of pretty much every product. And I would say that Google was probably like one of the pioneers when it came to implementing it, and when it comes to like innovating things with AI. Like it has been happening for decades, right? Which is why I would say that probably Google is uniquely positioned to help you solve all these problems that we face in like our day-to-day tasks, right? And which brings me to the three main pillars when it comes to transforming your business with AI, right? So what we want to see is like these three pillars are critical when it comes to harnessing the power of AI, I mean, including Gen AI and so on, when it comes to achieving fast time to value at scale with your data, right? So first of all, we want to make sure that we have the AI-ready data platform, right? So the ecosystem should be able to provide you with all the data capabilities that your organization will need out of the box itself. And this way you wouldn't have to use like 8 different products, for instance, to just bring something together for your project, right? We want to make sure that we have just one platform, and using that, the entire team gets to just work off that. And next thing is we want to make sure that we are able to leverage the AI capabilities and functions like the LLMs that you're using, or the embeddings, or the vector databases. And we want to make sure that, you know, all these capabilities are built into your data platform itself, rather than having to move your data to various different platforms. And, you know, for instance, like first off, you want to clean up the data in like a particular place, and then you have to move it to another platform just to do your prediction and stuff, right? So we want to make sure that all of this would be in one place. And the third thing is that we want to make sure that we empower all our users with AI, right? Not just the data scientists who have already had some experience with the ML techniques, for instance. So we want to make sure that regardless of what your current role is, you get to integrate it. And pretty much everyone gets to have a role when it comes to running these predictions. And you know, this way there would be lower barriers when it comes to you know, getting into the AI part of it. Okay, so here are some examples of customers who have already started using LLMs in their data analytics platforms. And you know, whether it comes to like the data analytics pipelines or their AI workloads. So we have, for instance, Priceline, who's a customer, and they've already, you know, started using. So, for instance, like the first session we had was talking about grounding LLMs, right? So, for instance, Priceline over here, it has already been using it for quite some time now, and this way they have been able to use. They have been able to support their customers when it comes to providing suggestions of hotels and so on when they want to plan their trip, and this way it sort of like helps with the grounding and to reduce like hallucination, for instance, right? For let's say if you were to use Priceline and you want to get suggestions of hotel based on like a trip that you're planning, and we want to make sure that it sends the right hotels for you to visit as well, right? So that's something that has been going on, and like millions of customers have been sending in requests, and based on that, based on the data points that they have and understanding the customer demographics and so on, these suggestions are provided to them. And other than that, we have Tyson as well, where they run smart factories with BigQuery, right? So with Tyson, they've already started tapping into the multimodality aspect of it, where they're not only using text, but they're also looking at unstructured data, such as like images and videos, to make decisions. And so this is more into the IoT side. So they would have sensors and so on to better understand the products, and from that, they would have to understand the data to optimize the processes, right? And the next one is Faraday. So with Faraday, what it does is it uses LLMs to directly pipe to enrich the customer profile itself, to better review the information, to understand their customers, and to understand how they use their products. And yeah, so they pretty much use BigQuery for this to bring in all the data, and then based on that, they get to extract these insights easily just on one platform. Okay, so over here you can see the entire portfolio that we have at Google, right? So first, we're pretty much focusing on all these different areas to support developers end to end, right? And for instance, like if you want to look into operational stores, you have LOIDB or Spanner. And then when it comes to blob storage, there's GCS, and then there's BigQuery to analyze all the data that you want. And then we have Vertex AI. So Vertex AI is pretty much built with all the leading capabilities with Gemini, and it becomes your AI platform, right? And then we have Looker, where we get to extract the high-level data insights that we need when it comes to like communicating whatever insights that you've gotten from the data that you've collected, right? So what we want to do is we want to make sure that we bring all the best capabilities to the entire data stack with the help of AI, right? Okay, so this would be the main highlight for us today, which is the part where we use Gemini and BigQuery, right? So it's what we're trying to do is we want to make sure that it makes developers efficient with the entire end-to-end process, right? So whether it comes from from the time where you build your pipelines up to analyzing it and helping you with designing queries and up to automating all the operations, right? Yeah, so I know like when it comes to generating your queries, it's the most crucial part where you tend to sometimes need some inspiration or support at times, where you would have to like go search up on different platforms, right? So with Gemini and BigQuery, you're able to prompt these codes itself. So for instance, you could prompt what kind of query that you want to generate, and based on the prompt that you've provided, it would help you generate the code itself based on the data that you have and the ones that you would like to use for your project. And yeah, so this way you would be able to generate the SQL code with the help of Gemini, and you would be able to, of course, alter it based on what you think is best as well. And you get to like proactively analyze the data that you need. And these are some things that otherwise would have been something that's more tedious, where it happens in a loop, right? With a lot of human interaction and all is needed. So with Gemini, it pretty much just makes the process a little easier for you. All right, so what I was talking about was the code assist feature, right? And what we want to do is we want to bridge the gap between just using natural language to generate the SQL code that you need. So with BigQuery, our focus is mainly going to be on the SQL part of it. So all you've got to do is like you've got to like type out the question that you need, just using natural language, just like how you would ask a friend or so on, and the code would be generated, as you can see in the GIF over there. So how this is done is because it's through the integration of Gemini into BigQuery itself, right? It's going to be similar to like how you would use a Jupyter notebook, just like how you would use like Python notebook, right? So same concept, but it's used for SQL. And yeah, so usually the traditional way would be for you to start a query by searching into the tables that you want to look at, and then you would have to add the columns and joins and filters and so on, right? And what Gemini does is it helps you get started with the new query itself that you want by just typing the prompt that you want. And it doesn't only understand the SQL semantics, but it also includes the understanding of the metadata itself. So it doesn't just blindly give you a code, like a general code, but it tries to understand the metadata that you have. It analyzes that first, and based on that, it helps you provide the suggestions or recommendations of how you could do the joins and so on. All right. And next up, we have the BigQuery data canvas. So this is similar. So it would give you a notebook-like experience as well, but this is more of a visual-driven notebook. So for instance, if you want to ask what are like the top 5 products used in Malaysia for your company, and you want to rank it by the states, right? So what it would do is it first provides you the table that you are looking for. It would provide it in a table, and it would rank like the top 5 products based on the states. And after that, if you want to visualize it, if you want to make it more understandable and like by stakeholders, for instance, all you've got to do is you've just got to ask it to help you visualize it, and it would generate you a chart, right? And it would pretty much just link it with the table that it had generated previously. And the good thing about it is that you get to construct your canvas in a way that it can be shared across your organization, similar to using the Jupyter Notebook again, where different parties can work on it concurrently, right? And yeah, so this is also because the LLM is directly built into it, so it pretty much does all the processing for you. All right, so this is another area that has been a very important thing for the team at Google as well. So right now, all of you probably already know what BigQuery is all about, right? So we have this large-scale data analytics platform, and then we have Vertex AI, which is our AI platform, right? And what we want to do is we want to bring these two together and make sure that we get the best out of it, right? So right now, I think most of you who are already in the industry would have noticed that there's this large gap in the industry, right? Between people who have true ML engineering experience and capabilities to act upon, and also those who are still getting started with SQL, for instance. And what we want to do is we want to solve this problem to bring more AI capabilities to the analysts as well. So not just the data scientists, but also the analysts get to work on these AI capabilities. And yeah, that's how that's the reason why BigQuery ML has been brought into the picture, right? We want to make sure that we have like a single class user interface where you could interact with both Vertex AI and BigQuery at the same time. So you manage your data, and also you get to get the insights and predictions and so on. You can do it all on one platform, right? And yeah, so after you store your data and so on, you would be able to, for instance, train your models, run instances. You want to do fine tuning or vector embeddings. Everything can be done on BigQuery ML itself. Okay. And yeah, so if we were to look a little deeper into BigQuery ML, right? What we really want to do is we want to make sure that we're able to do all the trainings and fine tunings, which generally needs a lot of lines of codes if we were to do it on like a Jupyter, on a Python notebook or so on, right? But with BigQuery ML, the good thing is that we give you a handful of lines of codes, and that pretty much does the entire process of it, right? So what we want to do is we want to make sure that the process is a lot simpler. And so, for instance, if someone is not too familiar with the traditional ML techniques, so all they have to do is like they just have to put in the prompt, and it would give you the suggestions of all the. I mean, for instance, just within like 3 lines of codes, you'd be able to see how you could get your model started and you can start creating the entire journey of it. So I know we talked about how we're using Gen AI and LLMs to support with the data journey, right? And of course, we wouldn't want to just stop there. We also have the traditional ML that's being integrated in it as well. So for instance, we have predictive ML, where you could do forecasting or anomaly detection, or inference, which is all built into the service itself, the BigQuery ML service itself. And other things we have is like we have the G8 model training with SQL integrations, like with Vertex. And then we have some recently released areas within predictive ML. So this would be more on multivariate and also time series forecasting and also explainable AI. And yeah, so the other thing is that we also have the multimodal support of Gemini 1.5. You know, I'm not sure if all of you have had a chance to look at some of the use cases where, you know, you could do all these summarizations and across like any different text capabilities, right? So that's also being integrated here where you would be able to run all these, for instance, summarization of your data on BigQuery itself. All right, so if you want to better understand how the Gemini models fit in the Gen AI data pipelines with BigQuery ML, so if you were to look at the upper left, you can see a handful of vision-supported techniques, whether it is to annotate the image or when it comes to like generating a text in the image. And very soon, our team would also be rolling out support for data types, like for instance, like videos as well, right? So once that's up, you'd be able to analyze video segmentations or like do summarizations and pull out information from a video directly. So right now we also have support for speech to text, where, for instance, you could you know, transcribe something based on like from the data that you have itself. And what you've got to do is you just have to feed an audio file, and based on that, you'd be able to pull out text for analysis. So we do have few use cases, like from large financial services companies itself, where they use audio files of traders to pull out, for instance, like entities such as like stock prices or purchases decisions out of the calls that are being made. And that would be stored as JSON files. And based on that, the analysis and so on, predictions are done for future issues. Okay. Yeah, so if you see over here, we have, we're pretty much managing in like all these different data types, right? So apart from the vision part, we also have the speech AI API, and then we have the doc AI API. I'll be talking more about the doc AI API after this. But essentially what we're trying to do is we want to make sure that, you know, we break this limitation where you get to get information out of unstructured data and also put it into a structured form so that you could do the analysis. Because right now, a huge number of companies you would see, they have a lot of unstructured data, but they're unable to make much sense out of it and make it useful for decision making and so on, right? And yeah, so if you see over here, one second. So this is the part where I wanted to share more about document AI, right? So apart from just using Gemini, we also have the direct integration right now, right, with our doc AI and speech to text services. And these are part of the native functions of BigQuery ML right now. So this pretty much, like I mentioned earlier, you get to use just a few lines of SQL code to extract insights and data from unstructured data. So using like doc AI, for instance, to parse large PDF files, for instance, or you know, you get to just transcribe these information from audio files and you get it into text and you get to do additional analysis all on BigQuery itself. And right now we have already integrated with Gemini 1.0 Pro model, right? Which is something that a lot of the customers have already started using, and they've already leveraged it in production on BigQuery itself. So Faraday over here is an AI-first customer prediction platform, right? And they have been leveraging Gemini inside of BigQuery to build AI analytics platforms to better understand their data, and also using Gemini, they try to do, for instance, sentiment analysis, or use the new formatted analysis output from Gemini in their downstream customer healthcare dashboards, for instance. And now let me just show you a breakdown of how these different use cases are being used. Okay, don't panic. There is going to be a fire drill happening at other floors today. So if you hear any announcements, don't worry, we're not affected by it, okay? It's only for other floors other than level 28 and 20. Okay. All right. Yeah, so for instance, like all the different use cases that you can use it for is like, let's say sentiment analysis. For instance, let's say you're working for a bank and you want to better understand how your customers feel about the new different packages that you're offering. So based on like the feedback that you've gotten from customers, for instance, the text might be too long and you wouldn't be able to go through it one by one, right? So if you were to do sentiment analysis, all you've got to do is you just got it prompted in natural language again. You just let it know, let the model know that you want to understand a particular thing. Just type it out and you get that, right? So that applies for when it comes to data enrichment or entity extraction or even content generation and translation. So for instance, right now, a lot of multinational companies, they want to better understand their market areas, like different demographics, right? So it wouldn't just necessarily mean that they need like, they're looking at a particular language. They want to make sure that they are able to support their customers across the globe, right? So that's also something that we're looking into. For instance, translation isn't just done at like for the major languages, the most commonly used languages, but it's going to be more inclusive as well, for instance. And yeah, so looking beyond the traditional text, like the ones that I showed earlier, some of the new capabilities that we have with Gemini 1.0 Pro Vision is that you would be able to pull out information from images as well and store it in JSON files in text form. So this is something new that you can work on as well when it comes to image analysis, or if there's any entity extraction that you would like to do from images. Yeah, so okay. Yeah, so here's a sample of how you could use Gemini Pro Vision for the prompting that you want. I mean, for running your models or creating a model and running it, right? So generally, you would have to write a long code just to get it done, right? So over here, all you've got to do is just write a 3-liner SQL code where you put in the prompt as well. So it's more interactive in a sense, where for someone who hasn't been used to doing the traditional ML engineering methods, they just have to write down what they want, and the platform would help them with that. So, and over here, this is where we fit into the larger picture of Gen AI pipelines inside of BigQuery, right? So we've already had all these functionality in place, and this launch highlighted in the red box over there will open up more possibilities for users who have been using BigQueries, especially when it comes to the vision part of unstructured data, right? So whether it comes to whether they want to work on image classification, or if there's any object detection, or for instance, visual captioning as well, it pretty much covers all these areas as well. Okay, so let me just show you a quick demo.
By now, you've probably had more than one aha or magical moments thanks to a large language model or LLM, whether it was chatting with Google Gemini on a browser or mobile app, or calling the Gemini API with a prompt. What if, instead of asking Gemini one question at a time, you could prompt it to help you analyze your BigQuery data row by row and at scale? In this video, you'll see how you can use BigQuery's integration with Vertex AI and Google's large language model family Gemini to analyze your unstructured, semi-structured, and structured data to gain new insights and enable novel analytical applications. Gemini can help you analyze your data in several ways, including text summarization, rephrasing of text, feature extraction, and sentiment analysis. It can also help generate new content for data enhancement, such as turning a zip code into a city. The Gemini family of models also has options that handle multimodal input, meaning a combination of text and image or video. This unlocks additional use cases, such as object recognition, captioning or description of images and videos, digital content understanding, and for information seeking by combining world knowledge with information extracted from images or videos. However, applying these use cases to a large dataset, say thousands of product images or customer reviews, would be a complex task requiring code and infrastructure management. Luckily, BigQuery's integration with the Gemini models through Vertex AI solves these challenges, allowing you to interact with Gemini using SQL and taking advantage of the scale of BigQuery. Getting started with Gemini follows two high-level steps. First, you'll create a model in BigQuery ML that references the model endpoint. Once the model is created, you can call the model on demand with the SQL select statement using the ml.generateText function. This example shows creating a model that references Gemini Pro, which handles text input and generates text as a response. If you're planning to use a multimodal model that handles both visual and text input, such as Gemini Pro Vision, you'll first make your visual data, such as videos or images, available as a BigQuery object table. Object tables are read-only tables that reference unstructured data objects residing in cloud storage. Once created, each row of the object table corresponds to an object, and the table columns correspond to the object metadata generated by cloud storage, including any custom metadata. Creating the multimodal model is similar to the text model, as you only need to update the options to reference the multimodal endpoint. Calling the model with ml.generateText does have slightly different requirements for multimodal models. The text prompt moves out of the select statement and into the struct itself, and the same prompt is applied to each row of the referenced object table. Okay, let's go to a demo to see this in action. In this demo, I'll be analyzing a set of movie poster images to understand more about the movies they represent. The multimodal Gemini Pro Vision model will accept the image as an input and will be prompted to identify the movie represented by the poster and its year of release. Then, the Gemini Pro model will take that movie title and year as text input and will be prompted to provide a text summary. I'm working inside of an embedded notebook directly in BigQuery Studio, which is an environment where we can combine Python, SQL, and even command line tools like gcloud and BQ to perform analysis. There are a few setup steps for working with Vertex AI models in BigQuery. These include enabling the Vertex AI and BigQuery connection APIs, creating a cloud resource connection, and then granting the Vertex AI user role to the service account used by the cloud resource connection. Next, I'll add our movie poster images to an object table. First, I'm creating a dataset to hold the new table, and then I'm using the create external table statement to create a table linked to the Google Cloud Storage bucket that houses the images. Now, I'll create the Gemini remote models in BigQuery ML. Firstly, I'm creating a remote model pointing to the Gemini Pro model endpoint, which I'll save in my new dataset and name Gemini Pro. I'll do the same thing with a second model, this time pointing to the Gemini Pro Vision model endpoint, and I'll name it Gemini Pro Vision. Now, if I go to the Explorer pane in the BigQuery console and refresh the contents, you can see I now have the new dataset with the movie posters object table, as well as the Gemini Pro and Gemini Pro Vision remote models. Let's use them to do some analysis. The first thing I'll do is use the Gemini Pro Vision model to help understand the images. I can send requests to the model by using the ml.generateText function, referencing the model in the parameters. The function syntax when used with the vision model expects an object table in the table parameter. I'll provide a text prompt within the function struct. In this case, I'm asking the model to determine the movie represented in the poster and to provide the movie title and year of release, specifying that that response must be returned in JSON format. Once the execution is complete, I can take a look at a few sample responses and their structure. I'll use SQL to pull out the movie title and release year from these responses into new columns. What if I wanted a bit more information about each of these movies, say a text summary of the movie? This content generation use case is perfect for the Gemini Pro model. Again, I'm using the ml.generateText function, this time referencing the Gemini Pro remote model. The table parameter will be a select statement that pulls the movie title and year into a prompt and asks the Gemini model to provide a movie summary. Note that the prompt for Gemini Pro can be unique to each row and incorporate data from the columns of the table, as I'm doing here with the title and year columns. It also requires the prompt to be provided in its own column named prompt and contained within the table parameter. This is slightly different syntax from the previous query to the Gemini Pro Vision model, where the prompt was provided in the struct. And the results, I now have the image URI, title, year, and movie summary provided by the Gemini Pro model. This data could be saved to a table or used in further downstream analysis, say joining it with other data such as movie reviews for sentiment analysis. Gemini's ability to turn unstructured data into a structured format enables you to draw novel insights and join that data with your structured data for even more possibilities. Accessing Gemini via BigQuery ML means you can do this at scale without complex code, needing ML expertise, or ever leaving your data warehouse. Try it for yourself. Check out the documentation and more resources linked in the description below.
Okay, so yeah, so hello. Okay, I think there was some issue with the presentation earlier. Okay, all right, the audio is fine. So if you were to go and check out the link that that was shown in the video earlier, you could further test out the model along with the documentation as well. All right, so we have another 10 minutes to go. Yeah, so the other feature that we have is the BigQuery vector search feature, right? And this is the part where you can use BigQuery ML to generate embeddings. So for those of you who are not too familiar with what vector embeddings are, they're pretty much the mathematical representations of a particular piece of data. And what it does is it gives the, for instance, from the context itself, you sort of like get to see the spaces between all these data to understand like what is closer. And based on that, you would be able to understand what's similar to a particular data point that you're looking for, right? And as you generate these embeddings and you put it into a 3D space, for instance, the embeddings within the same 3D space is what you would be using to determine which is the similar context that you're looking for. And right now we have this capability as part of the native feature of BigQuery itself. And with this, you get to generate embeddings directly in place and also use vector search to do all these similarity searchings. And the key is that when it comes to the similarity searching, we also have semantic searching for instance, right? And if you really want to get real contextual understanding using the language, we wouldn't want to just limit ourselves with the keyword detection, right? And which is why we have the BigQuery vector search feature integrated. And apart from that, we also have support for LangChain and also Vertex extensions. So you could also orchestrate use this with your models and also also with your own AI workflows that you may have already orchestrated with LangChain. And apart from that, we also have RAG over there, where if you give a prompt to an LLM and you want to compare the results you have already known to the embeddings that you have. So all you've got to do is you'd be able to generate the embeddings from the prompt with the vector dimensionality and compare with the answers that you have already had and you have already saved in your vector database itself. All right. Yeah, so this is a little more on the vector feature store that we have itself. So for instance, we have the BigQuery ML, we also have the BigQuery vector search, and then there's also feature store vector serving as well. Right. And here's a sample use case from one of our customers, which is Unilever. So they have been using it for their procurement strategy and insights, for their strategy and insights team, right? Where they would be able to use the, they would be able to communicate the data information from the raw data that they've collected itself to up till leadership and also buyers to make sure that they are able to drive larger strategic innovations as well. And when it comes to this, of course, data is a large aspect for what they do, right? And yeah, that's how they started with their journey with BigQuery. And yeah, so they pretty much started using BigQuery mainly to verify outputs of, for instance, the graph database query that they have been doing, and also to connect the data set with other pieces that they weren't able to find within their data lakes itself. And finally, they wanted to understand like what are the steps that they could explore to get LLM and their data together, right? To better understand and get the insights. And from there, they wanted to understand what are the next steps that they could take for their strategy and innovations and insights and all. So one of the initiatives that they've been working on was developing the graph database capabilities itself. And what they needed was the end-to-end traceability going from their supplier spend and how it rolls to their brands and business groups. So it was pretty much to go from A to Z within a few just within a few hops, right? And yeah, so they initially got the initial schema and query up and running with one of their partners, which is Tiger Graph. And along the way, they pretty much ran into a bottleneck where when it came to validating the output, that's when they started facing the challenges, right? And GSQL is the niche language that they hadn't set up at that point for the graph database, and it wasn't on scale either. So when they started running into minor issues, unpacking the JSON file, so initially they were using PySpark and Databricks and so on, and it happened to be they had a GCP sandbox available as well, and that's when they sort of started exploring the BigQuery auto schema detect scheme, and that's when they initially got started with using BigQuery. So this pretty much helped them help support them when it comes to productivity itself, and this way the analysts got to understand better what the outputs should look like when it comes to probing their data using SQL, right? So this way they didn't have to worry about clusters or scaling, and it was pretty much an iterative process where they had to go from the graph schema to GSQL and also the data validation, and it was all being done probably like 5 times faster than what it used to be back then when it was being done in a loop, right? And once they became more comfortable with loading the data set itself, they saw that the output was pretty much flexible, and they started they started coming to a point where they started tying the data to the historical ones, which was pretty much valuable for them because it was pretty challenging for them to tie back to the historical ones to understand the turnovers and so on, right? And over here, if you see the graph over there, this is the part where they started testing out for their sustainability sourcing teams itself, where they worked with the GE team to pretty much isolate greenhouse gas generation from specific palm fields that they're working on, right? And to link them back to the palm oil suppliers. So this is more of a sustainability project that they were working on, where they were taking data sets and linking them to the end-to-end spend data sets that they have generated. And they started to build up a picture of which brands were going to eventually end up owning the carbon dioxide emission and also through which suppliers this is mainly being impacted, right? So this really made them, it created the impact that they were looking for when it comes to their brand itself, right? To make sure that they're working on a sustainable project, and also to ensure that the carbon emission and all is being taken care of as well. So that's a sample. And yeah, and from there on, they took one step further and up till today, right? So now they're working with NGIS to better explore the form of like these palm plantations that they're working in. And of course, they have been exploring the LLMs as well to better understand the relationship between the data that they have identified as well. So they pretty much started off with the Palm 2 LangChain and BigQuery to build a basic talk to data kind of application where they get to just ask for questions and so on and get a better understanding, right? And since that use case was exiting to a larger procurement, and it pretty much inspired them to work on other use cases. So what they did was they started working on things such as, helping them to find all these, identify all these missed opportunities that they could have gone for, and also summarizing the pricing patterns or the cost drivers, and also identifying different potential shipping lanes, for instance. So they've gotten into like many different aspects as well using the LLMs. And after some time, once they got into using the APIs as well, so Doc AI and so on got into the picture as well. Okay, so that's pretty much it. And for those of you who are interested in building things on your own, so just now we saw a few use cases from other companies, right? So if any of you are interested in building things on your own, we have the Google AI developer competition. So let me just quickly run through this. Is lunch ready? Oh, okay. So I guess I can run this towards the end so that everyone can benefit out of it as well. So no worries, I'll share this link towards the end of today's session. So I guess since lunch is ready, I don't want to hold you all back any longer. So thank you.
Thank you, Amrita, for that sharing. Lunch is ready. Y'all can head out. It's just right by the entrance. Thank you. Lunch will be 45 minutes, yeah. So please come back at 1:15 for the next talk. 45 minutes. Ah, just like next.
All good?
Yes.
You're done for the day.
Yes, I'm done.
I don't know why this mic isn't working.
Is it this one?
No, I was using this, but it was kind of hard to like.
Yeah, it's a bit annoying. It works quite well. Maybe.
That works, but you've got to like bend down a little.
When are you becoming a GD, Amrita? When are you becoming a GD?
Oh.
Good question. Hello?
Sometimes.
Hello? Hello?
So we're about
Oh, I don't know. It's actually on schedule because we move out.
Hello?
Yeah,
but everything moves. So when is
we just move.
It's okay, I'm not that tall.
so we start again at
145.
Around at 145.
1:45?
We started what? Oh, okay.
Okay, so everybody
Okay.
moves
1:45,
in the afternoon moves with one. Because
3:45. You should be 3:45.
yeah.
Yeah,
Because
your session will be 3:45 because with your own Redis stuff.
yeah, okay. Good.
More time for you.
More time for me. Maybe I can rehearse twice.
Do you want to test?
Yes.
Because it seems a bit
that one just
like the
It's
mic.
not.
Sorry,
Oh,
I
I-
didn't get your name. You're
Sammy.
I can hear myself.
you're part of the
Hello.
GDG content hour.
Because even just now I could hear that.
Okay.
There was a little, yeah, but I thought maybe it's because you're
I was
connected to
wondering,
me.
Vandyck is a very Dutch name.
Yeah.
I mean, I
Did he choose that himself or
did.
really?
Yeah.
Because they're live streaming it as
Yeah,
well, which is
I
why they
read
wanted
his
us to
full
connect
name and I was like,
to me.
Okay.
Vandyck is probably not his real name.
I'm still able to hear
But that's a
Sammy.
really
Yeah.
okay.
Hello.
I think it's low.
I think it's that
Yeah,
and
it's that.
this.
You
I don't
paste
know
it
which one
together.
is.
This one's fine, then you just switch that one off.
Following up.
Yeah.
What?
She's your follower.
I know.
Mostly I just how it like.
Okay, let's.
Yeah, I need to know.
About EY.
What happened?
I made EY.
Oh.
So this is my senior, I guess.
Oh, it's okay. Okay.
Same team or
Yeah.
But when she left, then I joined.
Hello.
yeah, so it's telling me some stories from UI.
I'm still actively applying.
Elsewhere?
You guys received the application?
Do you know what you want to do?
Mostly data entry.
Okay, so what happened was they didn't all apply. Why? Because you said that
Because
only
I
can
like
be lead,
EPL.
the rest are gonna be like.
On cloud or just like in
Because
general?
they could have applied.
They were sure they
See who wants.
I'm still gonna be in the.
It's a tough market nowadays.
So I think it's again quite sad.
We got an advisor.
Yeah, but with all of layoffs, I think it's. I had a friend that got laid off in Singapore. I've been like, maybe you can try to. I think on the.
We have.
Like over the first year.
Yeah,
Yeah,
every time I think I'll work.
So they're giving us.
Yeah, but it's also not worth moving to a worse place. Like I've been in this position where I was not very happy, but it was like I also want to go to a place that I patience. I was going to ask Amrita for a break because I need to time my slides.
I think we have but level 20
Yeah.
I don't have the next one. It's not
Check.
the-
But here we don't have any.
Should I admit myself?
Yes.
No, it's always on.
Should make it stop snowing or it's fine if it's not snowing?
Your mic. Yeah.
Okay.
Yes.
Then when you share a slide, it should be on the spot. Then I share in Google Slides.
So I think last time
Share the entire screen. Okay, but I am doing a demo, so I think in entire screen. Stop sharing. Okay. It's very risky because actually something real can just ping me from there.
no, it's they will.
Yeah.
Okay, so it's actually I forgot the name of it, but essentially only when under the system pressure then it will take note.
Oh, seriously?
Yeah.
So the
So
view,
now the current one will go
so I
next.
just like sure.
Once it's not.
Oh, okay.
Yeah. So then going into the
It's currently displaying.
yeah. Right.
Okay,
Yeah. So
how much just
I think for Poland, you can how much that cost the try to do some of like let's say if I want to work genetic like that.
Yeah.
Yeah, you're a technical project. So your work is so yeah, so you just think I don't want to do that. Like you want to talk about you want to work on something. Like I think yeah, but it's more of memory fragmentation. So I think there's less issues because Java identification.
Yeah, because it's difficult to get feedback, right?
We wanted to make it Java but for my friend, that was Java.
Well, they just not that is a collection. And then we hiring a person. So
like for me, Java is
there's right
so basically like
that's right. I want to get something from
oh I just killed well, so basically, yeah, there's
have like laptop. Yeah. I have a laptop. I have a pyramid. Really kind of like it's really ugly to have like the chunky being in laptop. But if I don't have it today, try to find it. There's a picture.
Yeah, sure. Go ahead. Yeah, but you have to do a lot of implementation. But then, because I think I checked the last time, like Supercharge, there's 100 plus commands. Yeah, but then I have yeah, whoever tells
but you guys having
Oh, you can't do that. No way can use the pre-writing.
None of my business.
That's an interesting thing.
That's like the big issue was the visual license. Like I know something about that.
Sorry. It was a nice company. Y'all got too much.
Okay.
Like too much backstory. Like I had to be familiar with all. Give me something. Yeah, it's probably bad. Then that's the end of it. And then when I talk about this, oh, we have this Google area.
Yeah, the other Google that can you always do it and come across what? I mean, like, yeah, like, can do that. It's like, why? Why do you do it?
Have you had lunch?
Yes, yeah, but now it's like, yeah, everything. So it's like, oh, okay, where are you?
Is that the only one?
Yeah, there's another one here, but but yeah, it's just a lower thing.
Okay, I'll go there.
Is that okay?
Uh,
Did you see the room? Or?
Yeah, Sean's there, I think.
Oh,
I don't want to disturb him too much with. I want to let you talk
okay. Let me check it.
because it's, if you get if it's not then I'll call.
Hi.
Oh hey man, how are you?
Yeah, wow.
Yes, I wanted to see your talk with.
Yeah,
You were lost for a while. What's it? What again? They'll fire me. I pass. Oh, actually, like Apple boy, I'm a fancy watch. Yes. Come on, man. Yes. It's the same. At one of
Hello, everyone. I hope everyone is back from your lunch. If your peers are not back, you can ping them and ask them to join the room. We are starting our next talk. Right. So we will have Akshata, who is the founder and CEO of Kaius. She will be sharing with us about architecting AI agents on Vertex AI. Yep. Let's welcome her. And at the same time, we will also have track 2, Firebase has SQL by Shang-Yi at level 20. Thank you. Okay. Yes.
All right. How's everyone doing? How's lunch? See, there's a benefit to going after lunch. If I put you to sleep, it's not me, it was the lunch. Anyway, so if you'd like to follow along, the slides are here. Okay, I'm going to start off with a question. How many of you used an AI agent today? Yeah, nobody expected that. How many of you used an AI agent last week or have used one before? Okay. How many of you know what an AI agent is? Perfect. I'm all sorted. How many of you have used AI in general, Chat GPT? Yeah. How many of you use it in daily life? Much better. So 2 years back, actually, that number would have been even lower. But ChatGPT got introduced about 2 years back. And I think the reason that it took off so well is because it was rational, right? When you chat with it, you feel like you're talking to a human. It makes sense. It does throw jargon at you once or twice, but in general, it makes sense. Sometimes it makes sense even more than the other people you talk to. And that's powerful because one, it makes it lucrative in terms of your day-to-day tasks. You've actually started using it in your daily life. It's also the biggest criticism against it because hallucinations are the biggest problem in the industry. Anyone familiar with hallucinations? Can somebody give me a quick definition of what a hallucination you think is? You can speak up. Okay. Let me do that. So a hallucination is when the GPT starts to make up facts because it doesn't really know what it's talking about, right? So it's going to try to say something. It's like a 5-year-old trying to explain quantum physics. Okay, but let's assume that an LLM or a ChatGPT or a Gemini is rational for most part of the time. Now, actions speak louder than words, which means that if it's rational and is saying things that are rational, we can get it to do things that are rational. And that's powerful because we started off with software as a service where we are pulling together functions and throwing them at the user, and then we say, you go figure it out, whatever you want to do. You get to your result yourself. But when you have something that can think for itself in a matter of speaking, and it can think of for itself at power with a human in some way, then you can actually get it to do things and get the result directly. We are now coming to results as a service instead of software as a service. If any of you follow Dharmesh Shah, that's what he's been saying. And that's on the agenda today. So today I'm going to cover how we are getting from models to agents. When exactly do we start calling something an agent? Then we'll cover the basic concept behind an AI agent. The main theme is going to be how to build AI agents with Vertex AI. And then I'll do a short recap and takeaways in this space. Caveat, I'm also pretty new in this, so bear with me, we're learning together. And before we go ahead, introductions, my name is Akshata. I'm also known as Ato, or I am Ato. I'm a software engineer. I'm the founder of Keys, which is a tech consulting, and we build Web3 and AI ML prototypes for other companies. I'm also the organizer for GDG Cloud in Singapore and Practical Blockchain. I'm originally from India, but I've been in Singapore for the past 9 years. I'm a professional architect for cloud and buildings. I have a degree in architecture. I pivoted away. I figured out that it pays better to work at buildings than on them. That took a while to sink in. Huh? But the most important thing about me is that I'm a serial hotpot hunter. So if I'm not thinking about code, I'm thinking about Hairizuan. And I've not yet tried the Hairizuan in Malaysia. So if you've got recommendations, meet me after the talk. I would really appreciate that. Okay, anyway, back from hotpot. Let's focus on agents today. So how are we getting from models to agents? Like I put in a prompt, I go to a ChatGPT or I go to Gemini and I say something to it. When does it stop being just a model? When does it become an agent? We have to look into history because it's actually evolved, this process of coming to an agent. When you go and chat with an LLM, you're putting in your query and it's replying to you, and that's fine. But once you've done this a couple of times, you realize that there's a big gap. And the gap is that it can tell you factual things, historical things, but it can't tell you stuff about now. It's as dumb as not knowing what the weather is outside. Best case scenario, it'll tell me I don't know. Worst case scenario, it starts telling me it's snowing in Singapore and makes me get hopeful and then dumps me down the drain. So that's a big limitation, right? Because the LLM is essentially frozen after training. You're getting stale knowledge. And it has no access to real-time data, which means the limit of how useful it can be, there are very strong limits to that. So we were smart about it and we tried to correct that. And how do you do that? You put in RAG, or Retrieval Augmented Generation. How many of you are familiar here with RAG or RAG? Okay, so Retrieval Augmented Generation, what it does, it adds a wrapper around the LLM itself. So when you put in a query, there's a search mechanism or a retrieval mechanism which takes that query, which tries to find data sources in accordance to that query, brings together those pieces, connects it with the query, and then the query and the relevant data is passed to the LLM to make sense of and return the answer to you. So it's almost like an open book test for the LLM, or an open book question that, okay, this is the question, this is where the answer might be, take both of them and give me an answer, right? And that works. That really works for some use cases. For example, if you're doing customer chats, you're doing knowledge-based, you're talking to your PDF. How many of you have used Talk to Your PDF? Those are applications of RAG. And that's okay. But it still is not really decision-making. It's still doing language processing in a way. And that makes it very one-dimensional and, again, restricts use cases. And that's where we come to agentic AI. So for agentic AI, what this paradigm of thinking is saying is that you've got a rational model. Now let's wrap a whole set of infrastructure around that. We'll give it a planning layer. We'll give it an orchestration layer. We'll give it tools so that it can go and access data from different things, from different pieces. It can go and do things. It can go and compute things based on whatever it needs. And then we push all that out as one black box that the world can talk to. And that's agentic AI. Sounds good theoretically, but how do you build it? What are the building blocks of this? Now, coming to the definition of an agent, it starts off with a goal or a set of goals because it's a piece of software, so we have to define that. The main thing is that it's creating plans based on context, which again, we've had some exposure to in normal ways of using an LLM, right? Like how many of you have tried to draft your letter to your boss with an LLM, or an article or a project or something? Yeah, I see a very scared hand going up. It's okay, I'm not your boss. So we've already seen that at work, and we know that the model is sufficient for that. With agentic AI, what we are now doing is we are adding the decision-making, the execution, and the autonomous play. So we're adding reasoning tools and deployment and monitoring. And you could do it in as simple as Python or any other language that you want, right? You can build it from scratch. You can actually, it can be as simple as just writing a recipe like this. I say I want to build a landing page in Next.js. How many of you are software engineers here? Okay. What do the other guys do? Business? Anyway, so say I'm okay, maybe I'm trying to make a cake or something, right? So what are the planning steps for making a cake? I will decide what cake I want. I will do a Google search. I will get a recipe from the search. Then I will check if I have the ingredients. Then if I don't have the ingredients, I'm going and buying. That's my planning framework. And an LLM is able to do that, right? So I get a list of tasks that I need to do. Then I take the first task. Then I can say whether that's another planning task that I need to break down, or it's a task that I can execute. If it's an execution task, I execute it. If it's another planning task, I go ahead and create another set of steps and do that. And I keep doing that. I keep executing this till I get to my end goal, which is the cake is with me, right? So you can plan with models, which we've been doing right now. The decision-making can be a simple if-else construct in any language that you want. Then you have tools. These tools at bare minimum can be just functions that you're calling based on what the plan has told you. The plan can actually give you back that, okay, call this function now. And then you're just running a loop probably in whatever code that you're writing in, which works for simple agents, but it won't work for anything real time. Like I said it theoretically that, okay, maybe you can bake a cake with a loop. I'm not going to taste that cake if you do that with that simple loop. How many of you are familiar with AutoGPT here? Okay, so AutoGPT is an AI agent. And what AutoGPT is able to do is it's able to give you results for small tasks like go do research on AI agents and give me 1,000-worded article. Also publish it on LinkedIn, something like that. So you can assign tasks to it. Now, when you get down with complex pieces like this, you can't just do it with a loop because there are different considerations that come into place. For example, if I was making a cake and I've made that cake before, and say I confused an ingredient in the past, the second time I make that cake, I will remember that I confused that ingredient. That's human, right? For an AI agent also, you will have those memory considerations to make it behave in a way that will give you your results. How does it know that I made a mistake with the ingredient? Because I came to a result, something told me that this result is not quite right, which means there's something wrong in the steps that I took to come to that result. So I'm going to go back and now alter those steps and come to a new result. And then remember what I did in path 1, remember what I did in path 2, decide which one was better, use that better as feedback to do path 3, and in all possibility improve, right? So you're already talking about memory, you're already talking about feedback loops, you're already talking about monitoring, you're talking about evaluation metrics. And now suppose I don't just want to make cake for myself, I want to make cake for everybody else, I want to scale it. Again, how do you make this available for everyone to be able to do, calling multiple functions, calling different tools, without you actually having to interfere? So simple agents, yeah, you can do it in Python. But a complex agent like AutoGPT, you'll probably need way more pieces coming together. For example, these are just small bits of the prompts that are going into AutoGPT for like one loop. It's giving you, you're supposed to give it context first internally. This is not what it gets exposed to the user. This is what's happening internally. You're giving context to the LLM as to what is the role that they are playing. Then you're defining the goals to the LLM as to this is what you need to do. Then you also have constraints. For example, I'm specifying that your short-term memory is limited. So you want only a 4,000 word limit in what you store inside you that you can refer later. And that's all part of how you're designing this agent. Then I'm giving it a set of commands that it can execute or ask to be executed to get more information about the task that it wants to accomplish. And how am I giving it these commands? Like for AutoGPT, it's just text. I'm saying, this is the name of the command. This is the function you should call. These are the arguments that you can call it with. If you need this to be called, then give me a response that says, okay, call this function. I will call it for you. I will return the response for you, and then you can continue on. Then I'm giving it resources, that these are the resources you should go to. If you're not finding information in these resources, then just quit and say, I don't know, instead of trying to make something up. And then there's the performance evaluation criteria, which also it's going to take into account to determine what was the performance of this path that I took, so that I can save that somewhere and come back, pick that up in my next iteration. I can pick that up and then feed that back into the LLM when I'm doing the task for the next time. This is the response format that I'm specifying to AutoGPT as to how do I want the output to be. So for example, in this format, I'm saying, I want your thoughts, give me the text, give me the reasoning, give me a plan. The plan should be a bulleted list. Give me what you want, give me the criticism that you feel is the criticism that you feel for this plan. And if you want me to execute commands, give me the commands in this format so that I can actually loop through it and execute it. And all that to do manually is complicated. I would not do that. Rather, I would not do that repeatedly. At the same time, it's not rocket science. It's not something that each person needs to do once. or every time that they have to implement an agent. It can easily be modularized, it can easily be repeatable, it can easily be reused. And that's where we come in with Vertex AI. How many of you are familiar with Vertex AI? Okay. How many of you use Google Cloud in general? Okay. So Google Cloud is a platform that allows you to access computer infrastructure in different ways or forms. You can go down to just having VMs or virtual machines, or you can use packaged offerings like App Engine, which just allows you to deploy your applications and manage them directly. Vertex AI, and that is a unified AI/ML platform. So what that allows you to do is it gives you multiple tools and offerings to prototype and deploy production-grade AI/ML applications. And all these tools differ in terms of what they are good for, how easy they are to use. You can go very custom and very bare bones, and you can go to something that allows you to deploy a chatbot in a matter of minutes, and really sophisticated chatbots. So when it comes to building agents with Vertex AI, there are 3 key offerings that is beneficial to know about. And a lot of them are either in beta or preview. So it's a good time to just go and start getting familiar with it or start playing with it. It also means that for some of them, you get free credits to try them out. So that's another reason why you should probably go and play with it. But anyway, in terms of these 3 offerings, you can divide them into code or no code. If you're going to use it with code, then there's function calling and there's reasoning engine that's relevant. In terms of no code, there's the AI agent builder, which is absolutely it's literally click, 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 and you deploy your agent, which I'm going to demo later. But let's talk about function calling first. And function calling is the simplest that you can implement to get your LLM to start taking actions without too much overhead. It sounds exactly what it sounds like. You're just calling functions. It's just that you're calling functions within the Gemini native framework. So when you're interacting with Gemini, either directly via the Gemini SDK or via the Vertex AI SDK, what it allows you to do is it allows you to specify functions as native objects. So when you're passing in your query and your config to the model, it understands that you're specifying tools or you're specifying functions and tools, and it's able to react accordingly to that. In terms of flow, what's happening now is that as a user, you're pushing in your query to the application. The application is connecting to your model. When it's connecting to the model, it's already specifying the tools that you're going to use or the tools that the model is supposed to use. Now the model comes back to the application as to, okay, I need XYZ tools and the responses for those from those tools to go forward. So your application now goes and executes or invokes those functions. You get the response, and then you push it back into the model that, okay, for these functions that you wanted an invocation for, these are the responses. Now go ahead and tell me more. And this loop keeps going on till the model returns and, okay, end task, I'm done. This is the end result. And then the application pushes the response forward. So if you worked with a ChatGPT before, it's essentially the same thing as, okay, write me an article. This is from Wikipedia, then trim this. And then you're doing the multi-step when you're interacting directly with the LLM. Now, what you've done is that you've outsourced that to the agent itself or the model plus the application itself. They are doing the multi-step for you and then giving you back the result. Now, why this is beneficial is that it allows you to connect to external systems. It allows you to call functions. And it's simple to implement just to get stuff like, okay, what's the weather today? What's the temperature today? This is the API call. Get me data from this API and then use that in your logic. The fact that it's embedded in Gemini itself also gives you a lot of power, and I will show you how. So for example, this is what it looks like in code. So I'm using Vertex AI's generative models in terms of the library. Now, I need a chat function to go and check the Google store for some kind of objects. I can actually define 3 functions, and I can wrap them in this function declaration, which is a native object in the Vertex AI package. Now, you'll notice what I'm doing here is I'm giving it the name, I'm giving it a description, and I'm giving it an expectation in terms of parameters as to what parameters this function is going to take. If I was going to do that in AutoGPT or the example that I showed you before, that was just a text list, right? I was just saying, okay, this is the function name, these are the parameters, blah, blah, blah. But what happens here when I do it this way is that I'm still in the Python, for this example, I'm using Python, I'm still in the Python mode or Python framework, and I'm giving it very structured data around what a valid tool is and what this tool is going to do. Now, I take those 3 functions that I define, and I wrap them in something called a tool, which is another native object in the Vertex AI framework. And then when I initialize my model over here, I give it a generation config, and I give it the tools that it can use, that is, the functions that it can use. And now the model itself is smart enough to figure out that if you want the answer to this query, then I might want you to call this function first, give me the response to that, and then I will give you back your answer. Now, the fact that this is native and it's assuming that you're going to give me the answers to the function calls I make allows you to tap into even more functionality like forced function calling or parallel function calling. For example, and parallel function calling is again in a preview feature. But what that allows you to do is, for example, I asked Gemini, what is the temperature difference between Singapore and California right now? It probably needs to call one function twice, the temperature in Singapore and the temperature in California. Now, if I was going serially, then what it would tell me to do is call this temperature function for California. I'll call the function, I'll give it back. Then it'll say call the function for Singapore. I'll call the function, give the response back. And then in my 3rd step, it's going to come back and say, okay, this is the difference. This is the temperature difference between the 2. With parallel function calling, and this is enabled because it's a native object, what it's able to do is that it knows that I don't need to call it serially. I can call these 2 functions parallelly, get both responses, and then give it back to you in one round trip instead of doing 3 steps. So it'll just come back to me with, okay, these are the 2 functions that I need you to call. Call this function with California, call this function with Singapore. Give me both the results, and then I will give you my answer. That's shorter. Another benefit of using function calling is that the pricing is sort of inbuilt. So it works the same way as normal Vertex AI pricing, which is token-based. And it computes for you, it optimizes for you in terms of how to use your tools in the best way possible and how to optimize your prompt in that way. Those are the good parts. What are the bad parts? Now, if you saw the code, and if you could figure that out by looking at the code, if I have 5 functions, it works great. If I have a multitude of different packages, if I have 500 functions, that's not going to go. So it's not great for very complex use cases. The functions are also being invoked externally. So it's giving me what it wants, but the application itself is the one that is calling the function, which also means that the responsibility of calling the function right and then handling any errors with the invocation, handling any bad parameters or error responses lies on me. And then it's not really handling deployments right now. There's no production level deployments. It's just you're still calling the LLM directly. You still have to take responsibility for deploying your app into production. So it's not going to auto scale or anything. Which brings us to reasoning engine. Now, reasoning engine it's not an if or. It's not like you only use function calling or you only use reasoning engine. You can actually use both and you can build on each other, because reasoning engine does everything that function calling is not doing. So if I look at my AI ML application flow, I'm developing it, I'm deploying it, then I'm querying it with a client or a user, and I'm managing it. These are the 4 things that I need to take care of. In terms of developing, yeah, function calling helps me because it helps me build more autonomous agents. The deploy, query, and manage bit can be handled by the reasoning engine. And the best part about reasoning engine is that it's a managed service. So it's taking away all of your responsibility in terms of where is this LLM sitting, right? Where is this machine sitting? How are you managing the queries that's coming into the machine? What happens if something errors out? Does it restart or not? How are the tools managed? Where are the tools deployed? Can I go and create a cloud function and attach it here? Or can I just connect it to an external service and attach it? That's all managed for you. And in terms of frameworks, there are already existing open source and closed source orchestration frameworks to do AI agents. For example, LangChain is probably the most popular right now. How many of you are familiar with LangChain or have worked with LangChain before? Okay, some of you. So if you're using LangChain or LangGraph or Llama Index, you can use any of those and still deploy it to reasoning engine. So reasoning engine comes with customized templates, which allows you to plug and play, use any orchestration framework, and then use their runtime. It's actually a runtime to deploy it there. And it's abstracting away all complexities in terms of the DevOps bit of things. So in terms of monitoring, observability, what is the health of your instances and your system, it takes care of everything. I'm going to skip the demo for this in consideration of time. But what are the cons of this? Like any expensive sounding, big, all headaches managed service, this is probably great for custom solutions, but maybe not suitable for smaller use cases, both in terms of the effort it would take you to set it up and also in terms of how much it might cost you. It's also development heavy because it's assuming that you're already working with a framework like LangChain and building a very custom niche GPT solution. So maybe if you're making an agent to optimize packages on GitHub, where you actually need a lot of custom planning, code, reasoning, and you're using something like LangChain for that, then reasoning engine is a great way to go. But if you're using a customer chat and then just plugging it with PDS on the cloud, maybe not the best to use. And then finally, we come to the AI agent builder. And this is something that I'm really excited about because this allows you to go to a reasonably good chatbot integrated with a lot of platforms with no code and quite fast. But the most important reason to use AI agent builder today, right now, and don't quote me on this after a month or something, is that you're actually getting free credits to use it. So if you go and activate this API on your account, it'll give you a trial for Gen App Builder, and it's about $1,000 because it is expensive, but it also allows you to play around with it much better. Now, the benefits of using the AI agent builder is that you don't need to have machine learning skills. You don't need to understand the nitty-gritties of it. It allows you to just pick options and put it together as long as you understand the main concepts that we showed before, which was it needs to plan and it needs to have access to tools. It's also pretty great at integrating with other conversational user interfaces. For example, when we see the UI later, it's got integrations or plugins to, say, a Telegram or a WhatsApp or a Facebook chat that you can click and deploy and have your chatbot go there. You can also embed it into your website and then have it call functions native to your website. And then it's also good at taking multimodal inputs. It can also output in different models. It can output as text or it can output as synthetic speech. But the more important features about the AI agent builder are these. It allows you to have inbuilt routing to other agents built on the agent flow in the builder or other flows. So Cloud Platform has another product called Dialogflow, and this agent builder is sort of a continuation or goes parallelly with Dialogflow. And if you're using this AI agent builder, any other AI agent builder that you build in the platform, you'll be able to communicate or intra-communicate between those agents. So I might have an agent which is doing customer service only for my cake baking service. And then I have another agent which is doing customer service only for my hotpot service. And then they suddenly come together and my finance, and then I have another agent which is internal, which is like a finance or an accounting service. So my accounting service is going to be able to talk to my hotpot service and my cake baking service and pull together both results to get to something. It's also multilingual. If you've done customer chats before, especially in regional context, you will realize that that is a huge problem that exists. And natively, it is going cross-agent first, which is why it has features such as sharing input and output summaries between agents. So it accounts for the fact that if you're doing cross-agent, then you might have to share context between agents, not just the output input for whatever's the query that's being asked. So it has features for that. It also allows you to do custom model selection, so you're not like frozen into the model that they pick for you. And then obviously there are the hygiene and the maintenance features that come in, which is like you can ban phrases easily, so you're protected against your customers' inputs being not appropriate. You already have cloud logging and conversation history, BigQuery exports, those kind of handy features built in, so you can deploy it and then have the operational stuff still outsourced and managed for you to some capacity. And let's now get to the fun part, which is how do you actually go ahead and build an agent? Now, to get to that, it's hidden away. So you'll have to search for the Vertex AI agent builder, and you can go to the AI agent builder. I was already on the platform here. And then you can go create an app. And this is what we are going to be selecting. So it's still in preview. If I select this, I say example agent 002. Okay. So that was that. It took about 20 seconds to create. Now I can say this is an agent which is a digital assistant for IO extended care, right? And now I can say you are the digital assistant for the event Google Cloud IO extended. And then I can copy over instructions. And let's just go with some simple instructions first. And I'm going to continue the conversation. And that's it. I can save that. And I can actually start talking to my agent already in this interface. Now it has no tools, no access right now. It's just a simple LLM that you're talking to, and that's how it's behaving. Okay, so it's already welcoming us to Google Cloud Extend. How can I help you? Now, what I want to do is I already have a tool created here. Okay, maybe go to the tools. Let's shift to this agent. Yeah. I already have a tool created here. And what this tool is doing is that it's connecting to an external API that I've created, which populates, which gives it information about the events that are happening in this event, right? The way you define it is that you can have 3 types of tools in this agent builder. Open API is one, which is to connect to an external API. Then you can also link it to a data store, which can be something which can be something that you've hosted on GCP. And then you can also give it custom functions where you give it function definitions. But then that's for stuff that you're hosting in your own website. So if you're giving it a custom function, it's assuming that your client code is going to be able to access that function. So for simplicity, let's go with the Open API. I give it a description. And then what I need to give it is the Open API schema for the API that I'm going to use. I give it the endpoint as the server's URL, and then I give it a path which says docs. If I show you what this endpoint is returning, it's just a bunch of JSON, right? If I go here, it's giving, I'm telling it what the summary is, the description is, and this is important. So this is an operation ID, which allows my agent to figure out which function to call based on context, and we'll see the relevance of that later. And then we go ahead, give it the response type it's expecting, and that's all I need. Now, if I go back to this agent, this is an agent that I set up before, and I can link it up to the tool that I've used here. My sample is now using this addition in terms of the prompt. So I'm saying, okay, greet the users, explain your role. Now, if the user asks you any question about the event, use this tool to answer the question, right? And I can save that. And let's see if it does anything. So, okay, so how many docs are there in? Right. So now you see that it took the question, it interpreted that, okay, to answer this question, I need to call the tool or the function. Now it's gone ahead, called that function just based on the API schema that I gave it. It's getting this output from the function, the result. And then it's making out that, okay, there are 16 talks in this event, right? So say I am Akshata. Where is my talk? Right, that question didn't really phrase right, but okay. Now let's see. So it understands that who it's talking to is Akshata, and then it's going and finding what's the relevant talk or the answer for that. Okay. Now, another cool functionality in this is that you don't just have access to the tools. I can also say to answer questions about hotpot, use agent, and I have a hotpot agent somewhere, and use that agent to answer questions. I'm not going to demo that because the agent is a little crazy right now. So, but it makes you see that we are already going towards an agent economy of sorts. And it allows you to break everything down into little pieces and then cross-relate them. And that's where the power comes in. So you can take responsibility for 10 agents, then somebody else takes responsibility for 10 agents, and then you can go through all different kinds of pathways to address a huge set of applications just by this 10-minute or 30-minute coding exercise. Not non-coding exercise, sorry. Okay. So going back to the agent builder, let's do a quick recap do some takeaways. Now, what did we learn? We learned that agents have a goal or set of goals. Then agents are creating plans based on whatever context they have. They're making decisions, they are executing the tasks, and most likely they're doing it autonomously. So there are 4 bits to it: the model, the reasoning layer, the tools, and the deployment and monitoring. And in terms of summary, there are 3 things that you can take away from here. There's function calling, there's a framework with reasoning engines, and there's the agent builder. If you're doing something simple, you're probably using function calling. If you want no code, then you're using the agent builder. If you're looking at production level apps, your startup depends on it, then you're going with reasoning engine. In terms of limitations, a lot of them are in beta or preview. Agent builder is only supported for a limited number of regions. The reasoning engine has a learning curve. Function calling is mostly self-managed. It's only giving you access to 1 extra feature. But back to the main question. Do you think agents can really replace us? I see a nod there. Any other? Who thinks agents can replace us? Nobody. We're very self-confident, huh? Yeah. What agents are you talking about? Anyway, but I think I agree. We are definitely going towards composability and a multi-agent economy. So we will I think the number of hands that went up in terms of how many people used an agent today is going to double or triple the next time that we are back here, similar to how LLM usage has gone up. And in terms of the tools and the ecosystem and the frameworks that are coming in, you see a push towards that also. So every tool is providing a roadmap towards a native way of communicating, intra-agent communication. The concept of input-output summary is becoming prevalent. The concept of memory and cross-exchanging memory is becoming prevalent. Agents themselves could have defined identities and work with automated triggers, just taking in inputs from, say, this room or news or things like that and reacting to that. And even in terms of IAM services or cloud platforms, you can assign IAM identities to the services that are orchestrating these agents and go from there. But there are also significant challenges, which is why I believe that we are not going to be replaced with agents anytime soon. One of the biggest challenges is hallucination. One of the biggest challenges is going back to the first question that we came to. Are they rational? Can you count on an LLM or a model to be constantly rational and thereby take constant rational decisions? Until we've solved hallucinations, we can't truly have an autonomous agent economy working. There's also constraints on history and context. How much context can you actually give an agent in a universal way? How much history can they store? Even storing history on its own, you're having middleware and separate products that are taking care of this agentic middleware and solving them. Then decision-making quality. Now, your decision-making quality is based on what the LLM understands itself. Again, if you're doing something niche as trying to manage GitHub's manage packages in GitHub, then maybe you want additional context around how the AST or the tree structure works, how to optimize those, and then bring that back, which again wants your knowledge as opposed to something that is already there in a generic LLM, right? So there's human intervention there already. You're still automating. Then there are security considerations. For example, in terms of function invocation, we are calling very specific functions with very specific parameters. If those were open function calls, where something that I haven't programmed or there's just generated code calling something, I would freak out as a full stack engineer. I would, I don't think I would feel very comfortable doing that. And if I'm not feeling comfortable doing that, then can I really have a junior software engineer working on my team, just pushing code out and allowing free access to everything that I do? Then there's limited adaptability to dynamic environments and lack of common sense and understanding, but that's fine. Humans have a lack of common sense and understanding, so I'll take that. So yeah, I don't think we are quite there yet where agents are going to replace us completely. I think there'll still be an end layer or a control layer that we need. And hopefully it goes towards a future that looks like this, where the AI is doing the laundry and dishes so that I can do my coding and art and writing and hotspot hunting. And with that, if you are looking to learn more about designing AI agents, I'm putting together a GitHub repo, so you can follow that. And happy building. Hopefully you will go and play around. Yeah. We're doing questions, I think. Does anyone have questions? We'll get some agents to ask some questions next time.
Is there limitations to the number of
Agents you can create?
agents you can put in the
I would expect it to be, but I did not read a number as such. Invoking those agents in terms of the AI agent builder, right? That's actually expensive. So you'll probably be limited by the price there as opposed to how many agents you can create. Yeah.
how do they charge? They charge by
Calls, number of calls. Yeah. Thank you.
Thank you, Akshata, for the sharing. Next we will have Fong. She is our GDE and AI engineer at Cognitus. She will be sharing about RAG, Retrieval Augmented Generation. Let's welcome her.
Sorry, maybe you can have a coffee break while I try to set up. Hello, everyone. Good to see you are still staying back here. How's the event going on? Been a lot? A bit too at once? Or yeah, okay, no worries. AI could be a bit intimidating when you first learn about it, but yeah, actually hard to break it down to smaller components that it's easier to explain as well. But never mind. What's there? So for my session, I'll be talking about this multimodal RAG with Gemini, Vertex AI, Vector Search, and LangChain. You have heard a lot of RAG this morning, right? How many of you actually know what is RAG? Some simple words that you understand. Don't worry if you get it wrong. ChatGPT or Gemini also get it wrong sometimes, right? Yeah. Yes. And the difference is?
Either one is using the integer and another one is counting the external.
Right. A big plus for you. You are not sleeping in the event. RAG is actually link it to external source. But I'll also explain to you why we come to this solution architecture and what's not, right? You actually know it, but you didn't realize it. So without further ado, let's continue. Let's see. So for my session, it could be a lot, but I'll try to break it down into smaller components for you to absorb different concepts. But once you get that concepts in mind, then it's easier for you to do the coding part or even talk to some other people on all these things. When you talk everything together, you just get things too much agent and all this RAG and different terminology that you don't use and never heard before, right? It can be very, very overwhelming at the beginning, but fret not. Let's go through one by one today. So I'll go through a very quick introduction of LM and what's not. Then we go to the, again, still RAG. Then I'll try to break it down into smaller components, the embeddings, then the vector search. And then, of course, for now, the latest LM from Google is Gemini model. So we'll talk about a bit of Gemini model, how the Gemini model or LM model fit into the picture of RAG. Then some sample codes or some case study on how we do the multimodal vector search, and then we come to a summary conclusion at the end of the session. So good. You ready? Some quiz for you to keep awake. So introduction. Everyone here heard LM before, right? Some keywords for LM. When we talk about LM, what have you in mind? LangChain, yeah. Gemini. Promote a bit. And then the famous one you always been using. Okay, it's one of the LM, right? So LM is just the general term. ChatGPT, Gemini, all these are different models by different providers. So Google is actually the industry pioneer in AI. LM is just an extension or evolution from the past. It just doesn't happen immediately at the time, right? So starting from the very, very old time when we do the NLP process, the last time it's called the natural language processing. You may don't know the students nowadays still learn it as a basic or not, but then it's trying to do all these tokens and embeddings and all. Then as it has a power of learn, the machine is able to understand the text and then continue from there. It can actually build the sentence and all. So then it comes to a situation when this ChatGPT gets very, very popular is that the era of generative AI. We call it generative AI because the AI can start generating new content for you. It's just not what you give it. You just do the same sentence analysis. Is it a positive sentiment analysis or is a negative comment? It's just not that, right? But you can do, I want a positive comment. It will show you a very creative sentence of a positive comment. So these are getting very, very, very interesting. Since then, the market has grown and it's a big evolution in the AI industry from words. So with the LM in place, the next model that is coming into the place is, we call it, you may not have heard it before, it's VLM, or sometimes people just call it LM anyway. VLM is actually a visual language model where it comes into multimodality. So LM is just text. Remember when you play around with ChatGPT last time, you ask a question, it gives you a answer in a question in text, right? So it's text to text. But then people want more, right? The technology grows evolve from them. Besides text, how about image? You will ask. How about audio, a song and all? So then it comes to this multimodality. For Gemini, is actually one of the few LM that is actually taking in multimodality. You can submit in image for it to generate questions or generate another image. So it can be different input beside text, image to text, text to image, image to image. Then you can see the much more possibility can happen there, right? So things can be very, very, very fantastic here. A lot of ideas coming into the place because you can just combine different resources, data, the image and text together to build a much more powerful, let's say, search engine or recommendation system, because you just not bind to one text or image. So this is the evolution of the LM, right? So now, again, same things. The latest model, LM model from Google is Gemini. So welcome to Gemini era. Quiz. How many Gemini models in the family? Yes. 4. Can you name them?
Gemini 1.5 and Vertex AI.
And okay, you get the Gemini correct, but not the 1.5 or Vertex AI. Good try. Thanks for your initiative. Anyone else? Yes, your friend want to help. Yes, I would give you, there is 0.2 point, this is 0.5 points. Don't go for 1.5 or 1.0, all these are versioning. Coming up is already Gemini 2.0 already. It's not, I think end of June, we'll be announcing that. So not the versioning, but I think it's being mentioned by one of the speaker. Anyone? You already have it, actually, the Pro is correct. Okay. Ultra, yes. Pro.
Gemini Vision Pro as well, and then also there's Gemini Flash.
Yes, the latest one is the Flash, and last one. The very small one? Nano, yeah. Fantastic. So we have 4 in the families. Ultra is the biggest one, the most expensive and most powerful one. Then the normal one we will use, always use is the Pro version. Even in your AI studio and what's not, it's using the Pro. So it's a best model doing different tasks, but also quite expensive. Then now it's rolling out the latest one, the Flash. It's the lightweight model from Pro. It can do somewhat relatively good result, but then it's much cheaper. So if your use case is very simple, try the Flash version, because it will save you a lot of costing there. But if it's not, then you can compare the result between Pro and Flash. If no choice, then you go for the Pro if your use case is more complicated. Nano is always for embedded. Let's say you want to try on a Raspberry Pi or just a Nano and all these things, you can try to embed in using the Nano. Right. So far so good. 1.510 vision is the for visual one. If not, then it's I think the starting from Pro 1.5, there's not much a difference between vision and no vision. If you use the Gemini Pro 1.0, there are 2 models. One is vision, one is not. But 1.5, you can just put in the image or text. It can handle internally. Okay, so far so good, huh? So actually the graphic also got some meaning behind. You can see the architecture is the largest one, then you have the intermediate one, then you try to optimize again, roll out for the Flash one, then the Nano is the basic of the LLM. So you have a much smaller quantized version of LLM. So just to brief you, there's also open source model. ChatGPT is not open source anymore. So you have to charge, right? Then you have from Meta, you have the Llama model is open models. So what about Google, right? Google also encourage all these open models. So we have these Gemini open models. If you are free or you are attending the session next week on the Penang version, we'll be talking a bit on the Gemini models also. So stay tuned on that. ask it to print out the embedding, you will see the embedding is all these floating numbers. These are already transformed into embeddings. All good? All good, right. Any question? Then we go for the next concept. Okay, so this is the base components of RAG. Not just LLM. In fact, all the